He could, for example, hold up a cube and say, the 6 faces of the cube remind me of the 6 independent entries in the electromagnetic field strength. And then the idea is there's a duality, and the duality relates the electric field to the magnetic field. And then he might invent something called Olive-Montonen electromagnetic duality, right? So in other words, if I took the top 3, if I hold the cube up like this and I put electric above and magnetic below, and then I did a transformation that took top faces to bottom faces, he would be doing something that might bring him to recent research on electromagnetic duality. But instead, what's happening is that the spheres are reminding him of waves, like, wavefronts that are expanding spherically. And he's got super cool geometry that the reason that this is so cool is that we haven't seen much of it. And it's not saying that it doesn't exist. I'm not saying he's the inventor.
Well, I am the inventor because I own the patents to it.
But you can find out that there's prior art later. Look, everybody's been hurt.
I would love to see that.
Okay.
Like I said, though, I think Giordano Bruno
Terrence, I have no desire to take this way. So far as I know, you're the first person to do this. Okay.
No.
Now, with that said, you're taking something where he's saying real stuff about geometrical understanding based on a spiritual undertaking. And it used to be that spirituality and science were hand in hand. That's what I was trying to say about the Carolus school that figured out, almost got calculus coming out of religious verse, like stuff that rhymed. It's crazy. Terrence is coming from an older perspective where he's drawing tons of inspiration from all these different sources. I can track it, but good luck finding people who can track this, because the number of people who can do this is very, very small.
But that's the problem. Okay, go ahead.
Agreed. Now, then every time he steps on a landmine, my colleagues just start laughing. And that makes me crazy, because they could help him figure out what he is trying to say. So if we go back to his
electromagnetic tensor, how does this apply to these patterns in the void in between these patterns?
That thing we did not understand until the mid-1970s. Remember I tried to tell you to get Jim Simons on this podcast and then he just died? Jim Simons and C.N. Yang figured out, and this is going to figure into what Terrence is saying, that all forces are curvature. It's not just gravity, which we've known has been curvature since 1915, actually 1913 for Einstein-Grossman. It's actually the case that electromagnetism, the weak force and the strong force, are a different form of curvature, which might be called Ehresmannian curvature or fiber bundle curvature, which is not necessarily Riemannian intrinsic curvature. This object encodes the curvature, it encodes electromagnetism as the components of curvature. To your point about nothing is a straight line.
But this is where I have issues. You're talking about this is in Cartesian space. And in Cartesian space, curvature is not allowed.
Mm-mm.
There's no curvature that's allowed in Cartesian space.
That's wrong.
Really?
Yeah. Because what you have, and by the way, this is a super subtle thing. We've only really known this for 50 years, thereabouts. There is a weird, mysterious circle that none of us can see at every point in space and time that we can't derive from space. Okay? You can have space-time, and something else put a circle at every point that is obscured from us. And that thing has a curvature, even if space and time is flat. So we call the idealization of flat space-time Minkowski space. You can slap a curvature tensor of a circle on top of it, generate this. And it wasn't until, and this is mind-blowing, can we get the Aronoff-Bohm effect up here?
See, but that's where my biggest issue is, why go through all of those steps to define curved space with flat plane matrix when you have the definition of it right in front of you? That's why when you get a chance, I'd love for you to lay these out so you can see it predicts every distribution, every waveform. There's nothing that this doesn't predict.
I want you to think about, you ever play blackjack?
I've never been good at blackjack.
Okay, well that's
I've never been
because
good.
you're sitting
I always
there.
overbet.
You're sitting.
Always overbet.
You
Hit on
overbet
17.
and you're sitting there on 19, and you say, "Hit me," and all I hear is "hit me" on 19, and you keep going over.
Okay.
All right. Now, this thing here is a proof. This is a gift for you. This says we did not understand classical electromagnetism until the late 1950s, well after Mr. Maxwell. Now, what happened is we thought electromagnetism was that thing with the electromagnetic field components that we just saw. If you put a wire coming out of this plane of the screen and you insulate it where it says solenoid, can we just isolate that?
Mm-hmm. We can see it.
Yeah. Okay. Now you have this crazy thing, which is like you have a cathode ray tube at A, let's imagine, and you shoot it through a double slit, and you want to know whether or not there's current flowing in this insulated thing that you can't see. Now you think that the insulation is going to keep you from being able to tell whether there's current flowing. It turns out that the interference pattern changes whether there's current, even though there's no E and B fields outside of that insulated structure. And that proves that it cannot be the electromagnetic field strength that actually determines electromagnetic phenomena. What's really going on, can we call up the electromagnetic 4 potential? So one of the things is if you want to hang with the cool kids on any of this stuff, you don't try to map the electromagnetic fields because it's the electromagnetic 4 potential that's got it going on.
Look at that thing. That was cool.
I'm
as fuck.
looking for something that looks like A equals and then 4 components. Well, let's hit that thing, what you just had. That's good. That A, where you see partial derivative of A, that thing is called the gauge potential. And the gauge potential...
It's the force potential.
The gauge potential is really where the electromagnetism is happening. This thing over here on the right, the Faraday tensor, is a consequence of the real star of the show. A is the thing that matters. And we thought that A was a convenience product that constructed the electromagnetic field strength until the late 1950s. I think one of these guys who developed this, his name is Yakir Aronoff, who's at Chapman University. I think he's still alive. So in other words, we fooled ourselves into thinking we understood electromagnetism until the late 1950s, which is one of the reasons that you listen to your heterodox colleagues as opposed to making fun of them mercilessly, because you're not nearly as smart as you think you are. Now, most of the time, what Neil says is, oh yes, 1 in 10,000 heterodox people have a point. And Neil bets on the 9,999 who don't. And so he doesn't listen. This thing here is a proof that you can find elementary omissions very late in the game that change everything. And everybody who pretends that peer review works and that we've known this since antiquity, all this stuff, they need to understand the exceptions we've already found. If Terrence wants to do good, he would take that A with the new at the beginning, and he would say, okay, electromagnetism isn't about the electric and magnetic fields. It's about 4 of these suckers rather than 6 of those.
On a simple level, how would you describe electricity?
Well, I wouldn't know how to do it simply. Electricity is really, electromagnetism is really about rock, paper, scissors. In other words, is rock better than paper? No, it's worse. Then you do it around that thing. The failure of these things to knit together. If I had, Terrence, give me your hands. I want to put my hand over yours, and then you put
Go your right hand under. It's like jujitsu. Go right hand under, under, on your hand, and I'll grab his wrist. There you go.
That thing. Who's on top?
All of us.
Okay, the electromagnetic field strength. So now make your hand into like a plane. Measures the degree of the Escher staircase. The Escherness in that Penrose staircase is measured by that E and B stuff. Okay? That A basically is the the collection of hands that we had, the planes.
Right.
And
Jamie, show the Penrose staircase just so people know what the fuck we're talking about, because it's a very bizarre optical illusion. There
all
it
right.
is.
So the key point is the Penrose staircase is not just an optical illusion. It's actually an effect called holonomy. And those things are called horizontal subspaces. And the electromagnetic potential, which gives rise to the photon, actually is a series of stairs that appears to be in some kind of a contradiction. The curvature that he keeps talking about is the thing that actually resolves that contradiction. And in a weird way, the photon is a function, the photon is a derivative, and the electron is its function, and you use that derivative to differentiate the function. That's a crazy way of saying it, but at its deepest level, that's really what we are. We're in a geometry in which those flat planes say derivative equals 0, and you're trying to take the derivative of an electron based on this stuff. And geometrically, this only got worked out in Stony Brook, Massachusetts in the mid-1970s, except for a guy named Robert Herman, who nobody listened to in Boston, who was off self-publishing.
Well, let's consider one of the things that this is talking about. Again, this is where I have issues, because we're talking about two-dimensional or three-dimensional space that does not exist. We're still talking about imaginary things instead of talking about real things, like math's departure from where numbers started representing actual things. Math departed from that to where now math doesn't represent actual things. The numbers don't represent any true things. And so anything can happen inside the mathematics that they build from. But when you have the actual stuff, like what I wanted you to do, if you could lay these out just for...
I'm so worried I'm going to break
No,
these
you're
things.
not. I made these over the last few days. Just lay them out. If you have to move those other things so you could see. And what I'm talking about, the interesting
Bro, I
thing...
want to see a YouTube video of you in your lab putting these things together.
If you shine a light on these,
Yeah.
they end up creating all of the cymatics. No, don't even stack them up. I don't even want you to stack them.
All right.
I just want you to align them
Here, put a light to it.
like I'm saying. If you move this one out of the way,
All right.
and some of those, this will continually predict every harmonic node, every wave function. It will continue on. They overlap on each other to where any size, any crystalline configuration that somebody could hope for occurs. This is the supersymmetry that I'm talking about that defines the entire wave field. This is one part of, this is the crystalline electric wave field. That's not even, that's just one of the
How cool
crystalline.
is this?
Pretty
Now,
cool.
The problem that you're in right now is everything that you touch in this space made of spheres and platonic solids and whatever. You could spend your entire life, and I've seen people do it, staring into this and just finding cool thing after cool thing, thinking that you're seeing Jesus. I promise you, okay? I want you to hold this in your hand. This is made by a woman named Bathsheba Grossman. Pleasure to shout her out. She is a mathematical artist par excellence.
Shout out to Beth.
That is an 8-dimensional lattice called E8 projected into 3 dimensions, which is one of the craziest sort of sphere-packing gadgets. This is ultimately maybe the weirdest object in the universe. It comes from a 248-dimensional group.
Let me show you this in real life.
No, wait.
No, when you get a minute.
You're gonna bob and riff and all this
Hold
stuff.
on, let him keep going.
And what I'm trying to get at is, look, I want you to think about this legitimately as a drug, okay? And if you're not very careful with the mathematics that you're playing with, you are going to get so high. You are going to see everything connect to everything. And there's a reason that this stuff takes place in Islamic art. There's a reason, if I bring up, this is another version of the self-duality of the tetrahedron. And I believe in sacred geometry, they call this the Merkaba, which is like Hebrew for chariot. everything connects to everything else in this unbelievably beautiful way. And the concern that I have, Terrence, to be entirely honest, is you have to get disciplined about this as a drug, because otherwise you're going to see everything in everything all the time, and you're going to have the same repetitive conversation where people don't take you seriously because you're going to keep hitting on 19.
But if light passing through these show the same cymatics that we look at when we're looking at natural occurrences of individual frequencies, doesn't that become its own secondary proof beyond the symmetry of what it does?
Okay, you say geometry is a proof, and one of the things is you are at your weakest when you have you have an equal sign. No. You're your strongest geometrically. You're at your weakest when you have an equal sign. You say the dumbest stuff about equalities, and you say the coolest stuff about geometries. And I wonder whether you mean something. Like, it took me a long time to figure out what I think you mean when you do this riff on the square root of 2. Jamie, could I trouble you for that portal group /TH? Okay. If you do the square root of 2 challenge, right? You say, Howard's unbalanced equation. You say, okay, take the square root of 2. You cube it. That's equal to 2 times the square root of 2. That is illogical. It is unbalanced. It is unnatural. Now, at first, I had no idea what the hell you were doing. So I came up with something to prove to you that I'm trying to understand you. And I said, take the number of magi at Jesus' birth. He was born in the 25th day of the 12th month. If I raise the 12th root of 3 to the 25th power, and I take the fact that Jesus died in the 9th hour according to the Bible, I see the same Trinity rooted by the number of apostles. Now that seems to be like a profound statement. But the fact is, all I really did is I created an equation based on 2 numbers, x and y. And your version of it, I put in 1 and square root of 2. And in mine, I used 12 and 3. And the reason I got 1225 was that 25 is just 2 times 12 plus 1. So in other words, the danger of this stuff, right, is that when you start to see patterns and you start to see stuff that looks crazy, you don't realize what you're actually doing. What you're really saying is you're coming from a perspective that is philosophical before it's scientific or mathematical. And you have a statement which says everything is in motion. And then you go into a riff about loops. And you say, take out your calculator, turn it to the side, take the square root of 2, cube it, take that
divided by 2.
Then you do this thing where you happen to know the large decimal expansion up to a point, which is increases people's confidence. You got to be worried because that's like the confidence in con man too. But you make a point. We have a name for the thing you call a loop. We call it a fixed point.
A fixed point.
A fixed point. Now, a fixed point, you have something called a transformation. The transformation. Let me see if Jamie, if we can bring that back. So I'm just trying to standardize your. Can we go below that? Let me see. Okay, Terrence loop. You have a mapping, T for Terrence, from the real numbers to the real numbers, given by x cubed divided by 2. If you take the polynomial y cubed minus 2y equals 0, that factors as y minus square root of 2 times y plus square root of 2 times y minus 0. You claim that there's only one number that satisfies a fixed point relationship according to that mapping, which you call a loop. There are actually 3, 0, negative square root of 2, and 2. You make the correct point that if you iterate that for numbers above the square root of 2, it's going to go off to infinity. If you were to go below numbers of square root of 2 but above 0, it'll go towards 0. 0 will go to 0. Mm-hmm. And then you have the same thing below negative square root of 2. It'll go off to negative infinity. And above square root of 2 but below 0, I think it'll go off to 0. Okay? That thing is studied under fixed point theory. And you can look up the Lefschetz fixed point theorem, the Kakutani fixed point theorem, the Brouwer fixed point theorem. All of these are proofs that you have to have fixed points. Now I thought, why does he keep doing this riff? And then I realized that he's got a thing about everything is in motion. So for him, it's unnatural and illogical, you use both words, that the square root of 2 would be fixed under this iterated experiment. Now, that is not unnatural. There is something, I hate to say it, it's called the hairy ball theorem. Can we bring up the hairy ball theorem?
Before you put your hairy balls on my pieces.
That was good. Okay, the hairy ball theorem says that you cannot comb the hair on a rambutan without creating a colic. So let's see if we have any cool images of it. In other words, if you have a map of the wind that is going along the surface of a sphere, there has to be some point which is perfectly still. If you have a map of a sphere to a sphere, there has to be some point that doesn't move. In other words, what you're saying about things can't be still is not only incorrect, it is impossible to avoid stillness. And this is in part what John Nash got his Nobel Award in economics for, because he took work of von Neumann and Morgenstern on two-person games, turned them into multi-person games with a higher dimensional fixed point theorem, and said a multi-person game is more interesting because that's a market, therefore markets have equilibria. So you're saying real stuff in a way that fundamentally just doesn't, we don't know how to talk your talk.
Then
but we
teach
know,
me.
Yeah, I know.
Teach me. I'm learning.
What are we
I'm
doing?
learning right now.
Okay.
But Jamie, do me a favor. Pull up the calculator. I want you to pull up the calculator. We're going to look at this loop, and you tell me that this loop isn't a contradiction, and says that the math.
Okay.
Is, yeah.
Go ahead.
I want a scientific calculator. There we go.
Yep.
Okay.
Yep. Hit 2. Square root. It'll be over one more. I think that may be it. Yeah. Yep. Cube it. Hit x to the third. Up. No. Go back. Go back. Yep. Hit 2. Square root. Cube it. Up. Right up there. Yep. Now divide by 2. Hit equal. Cube it again. X to the third. Divide by 2. That is a loop. Cube it again. Hit x to the third. That's an unnatural
Talk
equation.
to me about unnatural.
It's a loop. It's a tuck inside of the matrix. It does not allow
No.
for math to make
No.
sense because of the identity principle.
Okay, Eric.
You're trying to say something. What you're saying is wrong.
But what I'm seeing,
No. What you're saying is fine. I agreed that you have a transformation that I called T. You can put those two steps together, which is cube and divide by 2. That thing is going to be dead still till the end of time. That's your point. And then you pass judgment on it. And you say that is not logical and it's irrational. And I don't know what you mean.
Well, because here we're multiplying something basically 3 times, and it's coming up to the same value as if we multiplied it by 2. And you keep doing that.
Yeah, well, I did that with
That's
the
a
12th root of 3, and I have a transform just like you.
But that 12th root of 3, that hypothetical
Yeah.
situation you put up there, does not affect the rest of mathematics.
Sure it does.
That loop right there,
Is your point that there's something special about the square root of 2?
I'm saying that the square root of 2 is a manufactured number because of the identity principle. If the identity principle was not involved, then they wouldn't have a problem with 1 times 1 equaling 2. Or
Why are you offended by 1 times 1 equaling 1?
Just because action and reaction, the universe, it's the separation of math from science when math was supposed to define physical things. So when they have things that doesn't align, we can't make sense. The rest of the audience don't understand. They're like, wait a minute, well.
Okay, objects in motion tend to remain in motion, right?
That was his first law.
But what do objects at rest do?
There's no object at rest.
So you have a problem with Mr. Newton.
There are no objects at rest because everything is sitting on something that's in motion. Everything is in motion within
So this
itself.
is like there's no straight lines in nature. So the idea is you're saying at some level that you don't believe I mean,
that
like, look,
anything's still.
I can
At a subatomic level.
That nothing's still, because everything in the universe is connected. So if you
But-
have one still thing, then everything connected to it also
Terrence,
has to be still.
If I understand what you're doing, and I try to steelman it, you're trying to say, look, first of all, the vacuum isn't a vacuum. It's roiling with activity, right? The void isn't a void. Stuff is happening. Virtual particles are coming in and out of existence. There is no vacuum, right? You're very much in tune with modern physics on that. You really are, okay? Then you have this idea of math is supposed to be about the physical world. It's not supposed to be unto itself. And if there is no vacuum, then there is nothing at rest, because the vacuum is going to be in constant quantum tumult. And then you get to the point which is something that is rest, therefore is unphysical, therefore it is unnatural. It took me a long time to figure out what the hell.
No, I'm literally saying there is nothing in the universe that is at rest, because everything is moving and communicating through vibration, and vibration requires oscillation, and oscillation requires motion.
So what you're trying to say is that if the universe at its deepest level is a quantum mechanical system in which there is no ability to create vacuum, in a naive sense, that the vacuum that we talk about is not the vacuum that people naively think. Therefore, any mathematics that references anything that is zero or still or whatever is invalid.
Is it imaginary? It's talking about an imaginary space.
Okay. I don't know what to tell you about this, because if I say something about a sphere, you might say, hey, Eric, what is the thickness of your sphere? All the points unit distance away from the origin. And I'd say, it has no thickness. And you'd say, show me one thing in the universe that doesn't have thickness. And then I'd say, well, wait a second. I'm talking to you about a mathematical structure that exists as math. And you're like, I don't want to hear about math that isn't immediately referenced to physics. First of all, that's not how this game goes.
When did math separate from accounting for physical things? Was the beginning of imaginary numbers?
The beginning of imagination. I mean, if I have a picture from AI of a woman that doesn't exist, but no, you can't tell the fact that that was generated by an AI, are you going to say that that graphics file doesn't exist? No, the graphics file exists. Mathematics has a physically independent structure. It is a system of logic. Then you have this very weird thing, which is, Eugene Wigner famously talked about the unreasonable effectiveness of mathematics in the physical sciences. But, David Tong, I think, talked about the unreasonable effectiveness of physics in the mathematical sciences. Many of us have had that for the last 50 years since Simons and Yang. And then there's also this thing which people associate with Max Tegmark, which is older, which is the mathematical universe, that the math is the basis, that there is a point at which the map becomes the territory, to borrow from our friends in the psychedelic community. Now, I can hear you, I can understand you, I can track you, but what you were doing when you were lecturing is terrible. It's really, really bad, because you have points. And by going over them and saying the super dramatic thing, you are in fact causing people who don't trust Tony Fauci, let's say, because Tony Fauci shouldn't be trusted, to say maybe we can't trust mathematics. Now, I have a lot of competitors, enemies, people I really don't like. I have stalkers who actually stalk my family and interfere in my personal life, who have PhDs, okay? My level of disagreement with them about the physical universe and the mathematical universe is essentially zero up to 1973. We don't really start to see a breakdown in the community of science, I think, until the 1980s.
And why is that?
Well, money. And power. Money and power. Ronald Reagan brought in a guy named Eric House to the NSF, and the universities stopped expanding and they started playing games. We had a thing called the Mansfield Amendment, which got the military out of science, which was a disaster. There's a lot of things that happened. Okay?
But imagine if science took a wrong turn when it walked down the road of relativity,
Okay.
in abandoning the ether. And now they've walked down this road, and now they realize that it's a potential dead end, but instead of turning around and saying, okay, well, let's use the luminiferous ether that all of these equations were built off of. And here a young man that's outside of the world has come in and said, okay, I have the wave conjugations that make up and prove the etheric nature, the etheric substance.
So
that's what I want to.
Jamie,
we got to walk
if we could
through
bring
the
back
pieces.
the portal group page, I can sort of show what Terrence is talking about, what his geometries, how he relates them to the physical world. So if we could go up to Howard's unifications claim. Okay. So you say you've come up with the grand unified field equation. First of all, he's doing something very unusual. He's saying grand unified, which actually is less than unified, because unified would include gravity. But he's also drawing from a group, I think, called the electric universe.
No.
Okay.
No. I'm drawing from Lorentz and Hein's work when they were deciding. They were trying
That's
to
why I wanted
prove
to check
that
with
it was
you.
electricity and magnetism. They could derive all of the effects of nature that we see from electricity and magnetism.
All right. So if we go down here, hopefully, because we just prepared this. By the way, shout out to Dr. Brooke Dallas, who put this together and just got her PhD from Caltech.
Congratulations.
Yeah, congratulations,
Hello.
Brooke. Okay. So all of this, these four things are how the community that you're trying to unseat thinks about nature at its deepest level. Now, let me see is there anything under there? Maybe not. So go up to, let's do David Tong's, because you brought up David Tong. Okay. I think I understand this, and I'm able to talk to you about it. Is this something, so this is my community and how it thinks of everything in the world. All right?
Right.
Do you have a way of relating what you think about in terms of what my community has wrong? Does this mean anything to you?
If you remove gravity outside of the equation, you take gravity out because
Okay,
gravity is affected. Gravity is actually covered by that strong electrical force.
Terrence, 1 second. Without, this is not a gotcha, and it's not
No,
me.
I know. I'm
Okay.
not. I'm just saying.
Do you know how to read this?
As best as we're talking about, I as imaginary.
Yeah.
You know, d to the 4. I don't know what the d represents.
So that's the volume element saying that you're in four-dimensional space and you're going to take an integral.
And y to a negative g, y to a negative gravity.
Yeah, that's the determinant of the space-time metric with which you might have an issue. Okay? So in other words, you're normalizing, you're saying that if the rulers look one way or the rulers look another way, according to Einstein, you have to put more weight or less weight on a region of space. Do you know what that R is? That's the foreplay, and then in the parentheses is where the stuff gets crazy.
Explain it.
That's what's called the scalar curvature. So after Einstein did his big general relativistic field equations, that was like Einstein scaling the shear face of Half Dome. Hilbert walked up the backside like a week later and said, you can derive your super complicated field equations from the simplest thing in the world, which is the scalar curvature. So when you say everything is curved, that R is the scalar curvature of Einstein's pseudo-Riemannian metric. And then, remember F mu nu? That's what we were just riffing on before. That's saying we don't know what to do with the electromagnetic stuff, so we're going to do the stupidest thing possible, and we're going to figure out how big it is and square that, and we're going to shove that into this thing to be minimized, which means make this as small as possible. So give me the configuration that gives me the least electromagnetic size. Then, because of 1954, a guy named C.N. Yang and his sidekick Mills, who didn't do nearly as much afterwards, said, you know what, the strong and the weak force are exactly the same structure as electromagnetism, and we didn't know that. So nature, in that first line from the R to the W, takes curvature 4 times, and 3 of those are doubled, like F, F, G, G, W, W, but one of them is singly in there, And that is really sort of the soul of the incompatibility, not what Ed Witten says about you can't quantize gravity. That's not the discrepancy. We've been lied to for a long time, in my opinion. What it is that the curvature that enters as gravitational and the curvature that enters as the internal forces, the nuclear forces and electromagnetism, occurs differently. One is Riemannian, one is Arrhenian. The line below that, Dirac, in that term psi bar d psi, is telling us the kinetics and the interaction through minimal coupling of the matter with the force that's in the line above.
Right.
And then the last three terms are the fudge factor due to Peter Higgs, because when he found out in the late 50s, a gal named Madame Wu, the Dragon Lady of Physics, told us that if you put cobalt-60 and let it beta decay in a strong magnetic field, all the particles come out spun one way. And that left-right asymmetry meant that you couldn't put in masses in a standard way for the matter, which is showing up as psi. So instead what we do is we have this thing, which is a field called the Higgs boson.
Psi is the wave function.
Psi is the fermionic wave function of the matter. That's the quarks, that's the electron, and that's all the neutrinos that are penetrating us all the time. That kinetic term, the DHs, tells us how this Higgs field will move. But mostly, you see, imagine that in this room it's 69 degrees Fahrenheit. Okay, you think that it's the same everywhere, but maybe where Joe is actually like 68.7, and over there it's 70.1.
There's a different frequency, a different
And so
space.
that H thing is said to have a VEV that varies slightly in the world, vacuum expectation value, because the vacuum isn't boring.
Right.
Now that V of H, that is the potential term that you neglect every time you say that all energy in the world comes from kinetics. That's not true. And that V, and there's a portion hidden in those FFGGWWs, which is pure potential. That last thing, which is not commented upon here, is called the Yukawa coupling. And that last term is how the Higgs field gives the illusion of mass to the matter, which was prohibited from having a naked mass because of the efforts of Madame Wu and Yang and Li, which is the same Yang of Yang and Mills. That thing that we just went through, which may have been boring to people, is the source of everything we know about the world at its deepest level, right? This thing right here, which might be called the partition function, is a Feynman path integral of this. And if you could understand what this is, we don't know of anything that isn't in what you're seeing. It's a whoa. Can I get a whoa?
Whoa. Can I get?
I live for those.
What now? Now this is the difference between having, they've been working on this for damn near 60, 70 years, but they don't have any physical models that represent any of these things. And if my physical models describe the electric force and the magnetic force and is able to account for all of the actions that takes place or the effects that we see, then it should be a better replacement instead of having to
Terrence,
go through.
you didn't do that.
I did do that. Let me show you.
All right.
Let me show you.
Okay, show 'em.
Now it's time to show.
Okay, here we go. I really want a YouTube video of him creating these things.
I would love that. So,
Just you with an acetylene torch.
I want them
whatever
in
you're
glass.
using.
I want them in glass, brother.
Yeah, somebody needs to make
yeah,
these.
well, I tried to do that before.
Well,
It
we
seems
have,
like someone could
we have a
3D
community
print
of
these.
mathematical artists. I want to hook you up.
I would love that. So this tetrian, as I say, begins the entire dance. It's I would call that would be Planck to me. That would be the proton. That would be the beginning of everything.
You map four different things to this. You say, one, it's dark matter
I said
because it's interstitial. Wait one second.
Okay.
You say, one, it's dark matter because it's interstitial. Two, you say it's hydrogen.
It becomes it takes.
Three, you say, well, look, it's got 4 electric and 4 magnetic because you associate the faces with electric and you associate with the vertices with the magnetic. You say, you go back to Walter Russell, who has this whole thing about exhaling and inhaling, expanding and contraction. It's a lot like Ecclesiastes. there's a time and purpose to everything under heaven. And then you say, because it's balanced as 4 and 4, it must be the weak force because there's no net voodoo on it. Okay? Then when you get to your, if you can bring up what you call the Huntian.
Hold on. Let's stay on this one.
All right.
Okay.
I say that this right here, like nothing in the universe does nothing for a single motive. Everything has multiple purposes and accomplishes multiple things. This becoming the geometry of hydrogen, or the very first visible element, is as a result of all of those forces pushing on it. But the first, I can use another hit.
Yeah.
I can use another hit.
It's called explainer juice.
Yes.
All right,
Yeah.
Brian.
So, thank you.
Thank you.
Thank both of you.
So, if we start with this as electricity, then we want to go to the very first phase from it. The first thing that happens to it is it decays. The first line of decay, and that first line of decay is literally just putting on 2 magnetic fields. If you'll hold that for a second, I've got to get something else out.
I gotta say,
Go ahead.
I love these things.
They're pretty
really,
dope.
They're really dope.
Yeah, you need a shelf in your office.
Yeah, for sure. I put this in my house, but Terrence, I just don't see.
We're not done.
All right.
We're not done.
All right.
So when you put,
Didn't you see the box it came in with, bro?
What kind of box?
That
No.
box of stuff.
so when they line up,
Yeah.
then they begin to create, and if you lay it down on your thing, you can lay them down.
Yeah.
And you'll see them align. If you can.
I want to design a skate park around these.
A
But
lot of sharp surfaces.
but-
Dude's going to get fucked up.
anytime you're urinating, a man is urinating, he sees this pattern where it's expanding and contracting. Expanding, contracting,
Right.
that braiding behind the boat. This describes that motion from that. But then let's go to the next stage of decay. The next stage of decay would be four sides. Now what these are responsible for, boom, boom.
How you doing, Eric?
All right, Joe.
Yeah, here
Yeah.
we go. And this is
The hard part for me.
That's the fun part.
Okay.
the part
Watching
I've
you
been
squirm.
waiting for. This is the part I've been waiting for. Now let's put this.
This is an
in.
elaborate hoax.
Yes.
My whole life's
And
an
I
elaborate
should-
hoax.
Now I should be putting the patents up so that everybody isn't out there saying, this isn't his shit. But so when you get to this level
Yeah.
of decay, they start to come together and they create this natural
How gorgeous
curvature.
is that? Look at that.
But do me a favor, they also create these spaces, and if you lay them out, one on top of,
Well, I'm still riffing on this one.
well, you're about to see that interact with the other side. Like we came to play today.
Boy, nothing like these conversations make me understand how different people's brains work.
Here
There's
we
just
go.
different humans out there.
Here we go. So, all right, if I can move some of your stuff.
By the way, I just didn't know what I was.
Yeah.
I brought like
No.
some weird tools in
So
case you were going to make weird
like,
points.
So if you're laying these
Yeah.
out, you're starting to see this pattern. But what's interesting, these have chirality. These
Yep.
spin in opposite directions from each other, but they ultimately reform together to fully tell that story.
So this is why category theory is so powerful, because your analogizing brain. I mean, let's be honest. I want everybody to form, without saying anything to each other, what is this most similar to?
The DNA.
All right, I was going to say the same. Right? And if it was DNA, what would be the interstitial between these two things?
That would be that ladder. Each line, it would be
That
the
would be the hydrogen.
ATCG, the hydrogen.
That would be the hydrogen bond.
It'll be
Okay.
phosphorus, phosphorus, oxygen, oxygen.
Now, if I was a protein scientist, what would I say this was?
You would say it's a ribosome.
I would say it's an alpha helix,
Oh.
right? I would say this was secondary structure in protein. So my claim is that one of the reasons that Rosalind Franklin didn't actually get to the double helix is that she was a really good scientist, and Watson and Crick were not good scientists. She said, "Look, I can see right through you. You just found out that Linus Pauling figured out the alpha helix in protein, and you wannabes who don't know jack shit about biochemistry want an alpha helix, and you want to do nucleic acid as an alpha helix, and look based on the X-ray crystallography of the Maltese cross, you're going to try to shove DNA into something so you get to be Linus Pauling all over again. And I don't want any part of it." And the problem for her was, yeah, helices are ubiquitous at all different levels, right? So in other words, Watson and Crick didn't own the double helix. What happened is that a very common structure that's going to come up over and over again, it's going to come up in viruses, where you have helical viruses, you have it in protein, you have it in nucleic acid. That structure is because there's a Platonic form, which you're finding here. You're going to find helices over and over and over again because you can't really have nature stop finding this structure. It doesn't belong to any instantiation of the system. And so everything is going to rhyme. Now, your big problem is that everything rhymes to you because you know a lot of stuff and you know a lot of similarities. Your brain's very good at that. And what your brain is not very good at is pruning the amount of rhymes that it sees.
Well, what I'm saying is this is defining all motion. We just define the motion behind a boat. We just define that other aspect. And remember, I was saying about the Huntian being a massless particle. It only exists as a result of these 4 to 8 tetraons pushing down because of pressure. The moment that these 8 tetraons disappear, that interior space, it's no longer there.
Okay.
The moment that disappears. So
I don't know how to stop you from doing this because
I hate doing that.
Well,
I
no.
hate you stopping me from doing what I'm not supposed to be doing.
No, I don't. Terrence, I'm so far out over my skis. I promise you what the internet is going to say the next day about me is, Eric Weinstein sees blah, blah, blah.
Don't read the internet. Stop reading the damn internet.
Okay, what I'm trying to tell you is you're taking all the good stuff that you're doing and you get into 19 and you're saying, hit me. And each time you do that, I want to slap you and say, don't do that. Because even if what you're saying is true, let's imagine that we find some structures like the ones you're talking about in wave fronts, right? I think what you're doing is totally canonical and it's very, very natural. And I think you're building models and you don't know how to do the algebra probably, and you probably don't know how to do the differential equations, all that. Fine, I can point you to books, I can try to help you.
I'm a geometer. I like doing geometry. I would love to work with a mathematician that can define and redefine these spaces and write new axioms if there's real axioms to be made from it or postulates to be made from it. That's what I wanted to do with with Dr. Tyson.
Okay, but part of what you're doing is you're coming into another community. Like what you said about David Tong is so unfair to David Tong.
What did I say?
David Tong. Okay. First of all, do you know who David Tong is?
I know him on the internet. I know, but I've watched a few of his things. Okay. I was very impressed with it. That's why I reached out to him.
He's amazing. And I have my difference. He's an acquaintance of mine. I haven't seen him since 2011. Okay. He's an amazing treasure because that guy has a gift for explanation in our community. And in a world where a lot of people in string theory have lost complete touch with reality, right? This guy knows every aspect of physics so well that he can explain it with razor-sharp clarity. So he's an absolute, he's a national treasure of the UK.
And I reached out and I said to him, look, dude, you're talking about these 16 fields. I said, I have the models for your 16 fields, which was
you're teaching.
Yeah.
That's, okay. If you want to say, I don't understand this, you get a positive reaction from us. If you say, I have something and I'm not quite sure what it is, can I get an evaluation because I think I might have something? You should be able to get something from a guy like me.
And that's what I did. I went to Oxford.
I know.
Didn't get that.
But I'm trying to say
went
something.
these
Okay,
cats.
go.
Okay.
Then you do this other thing, which is you teach. And your teaching is not good. You tell us stuff that's not true, that we can tell is not true. And then we say, okay, I can throw out the entirety of what he's saying.
What did I say that wasn't true though? That's what I'm. That's. I
Well,
mean,
one
my
times
whole-
one is not equal to two. Let's start there. In fact, I'm angry at Joe because Joe should have pushed back on that. Joe is in awe
The
of the way
calculator says 1 times 1 doesn't equal 1 because of that square root of 2
Can we pull
issue.
the portal group back up?
There's a lot of wild shit I don't push back on if I'm not sure what
No, I
the fuck that person's saying.
I understand.
That's why. But also because I know that people are going to eventually
But Joe,
respond to it.
right now we've got a crisis where nobody knows what to believe. And unfortunately
point.
for you,
I'm just saying
you were
there's
in a
a-
bad spot because you wanted to have fun. You had a show and it got really big. Okay?
That's
No,
why you're
I'm
here, Big
just saying-
Daddy.
Okay, wait.
I'm saying people have. If,
Can we go to the Terrence product? Maybe below that. Yeah, I think you were in the right place. Yeah.
Yeah, Terrence.
Okay. Here's how we would do this in mathematics. Assume you were a colleague, right? And I wasn't trying to get rid of you and get you out of my office. I'd say, okay, no, I'm not.
I know you're
I'm
not.
not kidding. That's
I
what
know
we,
you're interested and want to have further
But hold on, let him-
conversation. So go.
Okay. Standard thing, what we would do is we'd say, okay, wait a second. I don't really buy your claim that 1 times 1 equals 2, but let's try to evaluate what you're saying. Then I'd create something called the Terrence times binary operation star sub t. And I'd say that provisionally I define A star sub t times B to be equal to A times 1 plus B because your rule says that you should add A to itself B number of times. So that is the formula in standard mathematics for what you are introducing as times. Then I come up with the Terrence root of C equaling D if D Terrence producted with itself equals C. So now I have Terrence binary operation, Terrence root, and the Terrence square operation. And I say now, okay, now that's a totally legitimate object. Until you try to blow away times or multiplication in the normal sense, now what I've got is I've got a new operation and I want to know its properties. Is it commutative? No, A Terrence times B is not B Terrence times A. Those are two different numbers. Then I ask, is it associative? Yes, it is associative. So now I'm trying to make standard math out of the crazy ass shit that you say when you go to Oxford. And this is how I would start to understand it. I would say, Terrence, do we get anything new out of Terrence times Terrence root Terrence square? And I would therefore not incur the penalty that you're incurring. The penalty that you're incurring is when the rest of us work our effing asses off. And you come in and you say, I've developed, like, imagine if I got on this program and I said, is John Jones out there? He's a huge pussy. He doesn't know how to fight. I have a one-touch technique. And if I lay a pinky on John Jones, you're going to see a quivering little pat of butter. Sean Strickland has no disciplines. The guy's a big fatty. It's not going to go well.
No,
Okay. So what I'm trying to get at is that's what you're doing to us.
I didn't mean to. That's not what I meant to do. But in me saying 1 times 1 equals 2, like I said, that's a metaphor that there's something very wrong with the math because math should
There's
not be
nothing
done.
wrong with the math.
I'm
Terrence.
saying the math that we are doing is still based on linear projections, even though we are in a multi-dimensional space. And if the square root of 2 didn't have that
Terrence.
problem,
Listen to me very carefully. Assume you have the most beautiful curved linear object.
my
Okay?
wife.
Yeah. Can we do a form?
timing.
I don't want to talk about. I don't want my words about. I saw what happened to Will Smith. I want to keep your wife's name out of my mouth.
You'll meet my wife. She's very beautiful.
I'm sure she's dope. Okay. If you take the most beautiful ski slope you've ever been on and you imagine it was perfectly groomed so that there's just all it is smooth. You cannot create nonlinear smoothness without giving rise to something called the tangent bundle. And the tangent bundle is made up of linear objects. The nonlinear includes the linear. And it actually goes with your philosophy, which is that everything is an action and a reaction. The nonlinear creates the linear, but the linear encodes the nonlinearity. So if you actually wanted to practice, if you wanted to get as high as you could on Walter Russell, you would not try to deny the linear. You would say that the nonlinear is part and parcel with the linear, and that creating the nonlinear requires creating the linear. The differential operators at a point on a nonlinear structure form a linear space. And that's how we encode the tangent bundle when something doesn't sit inside of something else, because you hear that the universe is expanding. You say, well, what's it expanding into? Well, what we do is we encode that expansion without having a structure around it, no ambient space, by saying that the differential operators at a point are linear. So we've got an entire language that you don't know about.
But let's unpack that.
Sure.
For something to be linear, something to be straight, that means that it is no longer having to deal with the equal and opposite forces that nature puts on everything, because the greater the action, the greater the reaction, greater the resistance, greater the curvature. Everything in this universe has the resistance, and that's where the curvature comes from. So when they talk about, I don't mind them trying to go in a straight line or but the curvature of the universe is that phi at 1.618, that expansion aspect of it. That's the only consistent thing that you see in everything in the universe.
All right. If you take the concept of why is the cosmological constant almost zero?
I have no idea.
Well, nobody really knows. So you're not alone.
I mean, and them saying that the cosmological constant is zero, which means...
Do you know who Jim Gates is?
No.
Jim Gates.
Can you explain what the cosmological constant means?
Can we bring up the Einstein field equations with cosmological constant?
Is that the
dark energy?
That's that dark the quantum field that they, not the quantum field, the, what do they call it? The the vacuum.
All right.
Is that the vacuum?
So let's pull that one. No. I like that one. Okay. So that R mu nu is the Ricci curvature. That is a sub packaging of the full curvature. So you throw away a piece, like filleting it and you throw away the Weil curvature.
Plus a bivector.
Well, these are symmetric two tensors. Sometimes people call bivector. I find that terminology confusing. But yeah,
okay.
You're in the right neighborhood. That lambda is what's called the cosmological constant. And there's a raging controversy as to whether that thing is a number or whether that thing is like the temperature, which might vary subtly. And this was this thing that where Einstein supposedly said his greatest blunder was to put this in. He then found that you need this because Hubble shows that the universe is expanding. And then very recently, in the end of the millennium, they said not only is it expanding, but it's expanding at an accelerating rate. And that's when this whole dark energy thing really took shape. That thing, and where was I going with this? Oh, yeah. Jim Gates, who's probably the finest African-American physicist we have, brilliant guy at the University of Maryland College Park. He's a string theorist, so he and I are naturally like Montagues and Capulets, but he's a lovely guy, very, very brilliant. He says, look, we need supersymmetry because that thing should blow up. And it's almost zero. And the only way that it's almost zero is because the bosons and the fermions, if supersymmetry is true, have to be balanced, right? So imagine that you had two gods pushing on a door, and they're of exactly equal strength. The door doesn't move practically at all, not because they're not powerful, but because they're perfectly balanced, like unnaturally balanced.
And it's what happens when an irresistible force hits an immovable object.
Well, but these are two irresistible forces pushing in different directions and creating the immovable object between them, to carry through the analogy. So that thing has to do with a balancing between two incredibly powerful but opposite structures. And I think that you're negating the idea very often that you can have perfectly balanced things through fine-tuning issues. Now, one of the fine-tuning issues that we don't talk about, we usually talk about them in physics, but the most famous one should be the one in biology, which is before we had DNA, there was a guy named Erwin Chargaff, and he gave Watson and Crick the worst peer review in human history. He said that these are two idiots, that they were pitchmen in search of a helix. They didn't know anything about chemistry, and he totally dismissed them. He is the guy who figured out that the amount of A was equal to the amount of C and the amount of T was equal to the amount of G. And the only reason that that's true is because of hydrogen bonding that fixed the amount of A to be the amount of C on the other side.
Cytosine,
That's right.
guanine, and thymine.
And so the idea is that that was the fine-tuning solution. Why did you always have equal amounts of these things? Oh, because you didn't see that they'd been paired in a helix. You just saw it once it was broken. But the actual nucleotides had been paired, and so they're always the hydrogen bond enforced that. One was a double bond, one was a triple bond. This is like this. We're trying to figure out why lambda. We would understand better if it were 0, or we would understand better if it was enormous. The fact that it is almost 0 in a world where the vacuum is filled with crazy stuff, to your point, this is one of the greatest reasons for, this is probably the greatest, I agree with Jim, this is the reason for supersymmetry. Without supersymmetry, we don't have an explanation for why that thing doesn't blow up.
So if you saw a geometric structure that defined and worked together completely, would this qualify as a supersymmetrical system?
Well,
and we haven't even got
yeah.
to the magnetic field yet, but you see how these things fit together and what they might do in replacing.
So you have a metaphor, and you have a metaphorical mind. So you have this thing that you call what's the tetrahedron one?
The tetrahedron.
Tetrahedron. You got one called the Huntian.
The Huntian, that's my son.
Okay. And then
The
you have
Aubrian.
you have a different one where the Huntian is flanked by two tetrahedron, which you call a transformer because it's
I call it a light unit.
Down.
I call that
then
a
you say
light
it's
unit.
a photon.
Yes, it's a step up and step down transformer.
And then here's how your unification scheme goes. You say, look, I don't need gravity because I simulated Saturn without gravity. By the way, electromagnetism looks very similar to gravity, which causes all older
That's what
electrical
I've been saying.
engineer.
Electricity is the cause of gravity. Gravity is an effect. It's a draft, like the thermos.
Will you
is a
stop
draft
teaching,
of
man?
radiation.
You
I'm
gotta
sorry.
stop teaching
I'm
because
just-
you're saying interesting stuff, and then you just always go over.
Okay.
Look, you want to know what the DMT of this stuff is? I'll hand you the stuff that'll blow your mind. Right now, where this is something called the double copy. The double copy is a relation that was totally unexpected between the amplitudes associated with gravity and the amplitudes associated with the Yang-Mills stuff. And I just met with a guy, Zvi Byrne, at UCLA, who's one of the guys who brought us this double copy. And it's a great mystery. It's like looking directly into the equimolar relations before you have the double helix. So there is a relationship that is much deeper than the superficial relationship between, can we bring up the Newtonian force of gravitation?
And then let's do a bathroom break.
Sure. We
After
could do
that.
one right now. We could do it right now. Do a bathroom break right now.
Yeah.
We'll be right back.
No.
You don't know who he is?
No, the last 3 weeks, all I've been doing is watching your shit.
Bob
Watching
Lazar.
you. I'm like,
Me?
I'm
Yeah.
like, let me see what.
Oh, man.
Bob Lazar was a guy
I
who
caught you on
claimed.
TMZ suddenly talking about me. It was like, what is my name doing in Terrence's mouth?
That's hilarious. TMZ asked you a question
Yeah,
about
and
him?
they said,
That's
do I
hilarious.
have anything going on? And I was like, yeah, me and Eric Weinstein. I said Weinstein.
Stein.
I said Weinstein because Brian Keaton said Weinstein. He said Weinstein,
Weinstein
on the
is
thing.
Weinstein,
He was
not
being,
Weinstein.
Yeah.
Yeah.
So it's Weinstein. So
It's
I
whatever
said
Harvey
Eric
is.
Weinstein.
Keating said
Yes.
Weinstein? Is that what you're
Yes.
saying?
He said
said it
Weinstein.
wrong?
No, he said Weinstein. So I thought I said Weinstein, but I didn't
Okay.
know if that was just a joke or a play on
They got
things.
super
or-
sensitive after Harvey.
Yeah. Shoot, I don't.
So what we were talking about was Bob Lazar, who's a guy who claimed to be back engineering UFOs for the government back in the late 80s. That's what we were just talking about.
I did see something about him.
Yeah. He was on the podcast many years ago. It's a fascinating story that I hope is real. And that's what we're discussing, like whether or not Eric could make sense of it. So that's what we're talking about. We walked in here. What were we talking about right before we went for our bathroom break?
He threw up an equation. Not threw up.
The Newtonian, and then what was after that? We're about to
do the analogy between electromagnetism and gravitation,
Right.
Newtonian gravitational
Okay.
force law. So we have these inverse square laws, and because of the similarity, can we do the electromagnetic force law with two charges separated by a distance of r? Joe, who has smoked weed in this while we're waiting for it? Okay.
nobody.
Okay, just Elon. He's the only one who. Okay. So if you look at, let's do the electromagnetic, the Fe equals KQQ over R squared.
This one?
Yeah. Okay. So fix that in your mind and imagine that I turn the Q1 and the Q2 into masses and the R is the distance between them. And that K becomes a different constant. So now let's do Newtonian gravitational force. Okay. You can go above? Yeah, let's do the one with the two big spheres right there. So you see that it's like very, very similar formally, right? There's a constant in front. There are two different objects and there's a distance. So one of the reasons that I wasn't, I have the same feeling you do about that Saturn hexagon. Like, what the hell is that? It's unexpected. And I've never understood this great red spot on Jupiter being if it's a gas giant, it's so stable for millennia. The whole thing doesn't super make sense to me.
It's going to give birth to a moon.
Okay. So partially what happens when electrical engineers get older, they start to have this idea about electricity and gravitation. And you get this stuff about electric gravitics. Sometimes people call it gravidodynamics. And the formal similarities between these things appeal to people, and they want to see one as the other, right? And of course, the Kaluza-Klein theory tried to connect gravitation and electromagnetism super early on. So part of what happens is that Terrence tries to say, look, I keep coming up with these ideas of somehow wave fronts. The wave fronts create these shapes that are related to the Platonic solids, but curved linear versions of them. He associates the tetrahedron with the weak force. He associates the octahedron with the strong force. He associates an octahedron flanked by two tetrahedron, all curved linear on opposite faces with the photon, i.e. electromagnetism. He replaces gravitation. Then he says, weirdly, that he has a grand unified theory because he doesn't have gravity, so he doesn't need to put gravity in because of the similarity. And then he's got these shapes. And the disconnect is between the shapes and invoking forces, right? In other words, there's a moment in the story in which it's just this massive leap.
From the shapes creating force?
Well, it was the issue in which I tried to show you the Lagrangian inside of a partition function for encoding everything. And in order to unseat, let me just give an advertisement for the establishment.
The Lagrangian, most of the time when people hear Lagrangian, I'm just saying this for the Lagrangian points are those points in space where the magnetic fields meet up into where there's almost a balance.
Same cat, different issue.
Okay.
Like when ZZ Top is singing about Lagrange.
No, that's what I was saying. When most people hear Lagrangian, that's what they're thinking is Lagrangian, but I'm sure you're thinking about something else.
No, I'm thinking about an objective function. I'm thinking about something to be minimized. In effect, normal human beings think about physics in equations, like Einstein's equation or the Schrodinger equation or all this kind of stuff. Physicists don't think in that way. And if you permit me an analogy, imagine you have four forces, and the four forces are analogized to the four different configurations of the Beatles. When Ringo is singing Octopus's Garden, he's in front and everybody else is supporting, right? So when it's, Well, My Guitar Gently Weeps, George is out front. Penny Lane is going to be Paul, and Strawberry Fields is going to be John. Those 4 different configurations of the Beatles are all the Beatles, but they're different configurations, right?
Yes.
And the equations are like the different configurations of one person in front and everybody else supporting that person. But the Beatles is like the Lagrangian, right?
Okay.
So the Lagrangian is a machine for creating those 4 configurations. Now, in the case of physics, right, you have these different equations for the different fields. The gravitational field equation has gravity and the metric out front. The Yang-Mills equation has the photon, the gluons, the WZ particles out front. The Dirac equation has the matter out front. And the Klein-Gordon equation with potential has the Higgs field out front. And those are the basic fields of reality, so far as we understand it.
But the Higgs field is responsible for like 1% of the force applied upon them, right? It's so that I understand the Higgs field.
The Higgs field has to do with the fact, like, none of us are zipping off at the speed of light, yet we're all made of matter that has an asymmetry due to the weak force. If the weak force was not around, we would not need the Higgs force and the Higgs field to generate an as-if mass. But because of the asymmetry built into the weak force, which is the only thing that has this left-right asymmetry, we can't have normal mass. There's a place to put a normal mass in the equation that's forbidden if the universe is left-right asymmetric. This has to do with this thing called the tau theta puzzle from the 1950s. We were freaked out. Can we get a picture of Cindy Crawford?
That's a good transition.
Well, no, it's important.
Like it.
So, by the way, I'm dating myself because, okay.
How old are you?
What?
How old are you?
58.
Okay, you got me by 3 years.
Well, you said you were a young man. I was flattered to hear.
I'm 55,
Okay.
so we're good.
Now, let's notice how beautiful this woman is and the fact that she's asymmetric, right? And the asymmetry has to do with a mole that she didn't remove from her face. So we can tell when you have an image of her, like if she wasn't holding a can of Pepsi and she wasn't next to a Pepsi machine, you wouldn't be able to tell, but for the mole, whether you were looking at her or a reversed image of her down the center line. So Marilyn Monroe, Sidney Crawford have this left-right asymmetry to them. That thing is like the weak force. It's the only thing that can detect this difference between left and right. And the weak force is the thing that prohibits a normal mass that forces us into a Higgs mass through something called a Yukawa coupling. So that's the whole reason that it's in that thing, is it's a crazy Hail Mary to save all of physics. Because normally, if the world were left-right asymmetric due to beta decay, the thing that causes a neutron to decay into a proton and emit an electron and an anti-electron neutrino in the process, that process is the thing that denies us mass. And we would be at the speed of light, and we would all zip off in opposite directions, but for the Higgs field.
And that process is the radiative process. That's the process I call magnetism that that tears apart, that rarefies that which was concentrically drawn together through electricity. That weak force is an equal force to electricity.
Terrence, let me ask you a question.
That's what I feel.
I'm taller than Joe.
Right.
Imagine I challenge Joe to a fight. What do you think happens next? I get my ass kicked.
Well, Joe knows some shit that you
Joe
don't know.
knows some serious shit. I have an advantage on him in terms of weight. I have an advantage on him in terms of height. He's in great condition. The guy knows how to fight, and he's got a spinning back kick to die for, okay? What happens is I get my ass kicked. You do not know when you're going to get your ass kicked. And it's a big problem that you're going to keep courting, because I watch you. You keep finding the space where we could come together, and you insist on teaching into it. And it's like, I'm trying to be nice as pie because I'm inspired by what you're trying to do. But you have no idea, like, when you're fucking with a guy with an Italian last name and a shiny suit with a funny collar that you don't recognize. You got to stop.
Yeah, and I see the metaphor in it. And
Can I ask you, before we go on further, you feel that the theory of gravity is incorrect, and there's something else that accounts for all of the effects that we call gravity.
Yes, I feel.
And what do you think that is?
I feel that's electricity. I feel that gravity is the draft left behind from the electric force. As the electricity moves through, there's a draft that's generated because it creates whirlpools. Each of those whirlpools is the gravity or the cosmic foam, or I forget, there's another term that they were using for this foam, but it's a flowing in it the same way that thermals are effective by by magnetism or radiation, creates these thermals that you're able to fly on. The opposite of those thermals, I believe that gravity is the opposite of those thermals in the electric force. It's the pulling down the same way the thermals push up.
What do you think about that?
I don't even want to touch it. Well, because I'm going to get into the same thing. I'm trying to say to you.
I know, and I'm just saying, and I could be wrong, because based upon what I am putting together is taking commonsensical geometries and taking definitions of words and putting them together in a manner by which the layman sees it. Because the whole point is for everyone to understand science.
But you're teaching repeatedly. And that is going to be your downfall.
No, I'm listening. Right now, I'm a student. Now, I swear to you, right now, I am a student right now.
I don't know how you generate all that stuff. Like, I've tried to understand your mind. I try to do this by the way, this isn't peculiar to you. So far as I know, I'm the only person who's tried to understand Peter White's theory of the universe, Garrett Lisi's theory of the universe, Stephen Wolfram's theory of the universe, your theory of the universe. My colleagues don't do this.
See, I thought I was
I'm stuck.
special.
No.
You just made me feel not special anymore.
Brother, you were certainly special. That's not what I'm trying to say. What I'm trying to say is that physics and science is broken down. I will steel man you. I will try to put your best foot forward. I'm not out to get you. Where we are right now is that the Brian Greens of the universe will not look at anything that isn't string theory. They're really like that. So whether it's Ed Witten or Sean Carroll or Neil deGrasse Tyson, this generosity of spirit, the spirit of collegiality, it's dead.
Yeah.
Okay? And what you get is gotcha artists, right? And that's all they do. They're just trying. There's also something called gripe and swipe, where they try to find any flaw in what you do so that they can throw you aside, and then they can take every right thing that you did and put it under their own name.
That's why I patented. That's why I patented everything before doing it, because I thought that might be the case. Because I went to somebody at MIT and I showed him the wave conjugations. I can't remember his name.
Because it's a small community. We all know each other.
I will remember his name by the time I'm done. But he said, "Oh, I've seen these before," and I was like, "No, you wouldn't. No, you haven't, because if you had seen them, I wouldn't have the patent."
So this is part of the problem: is that what you need? And this is a very important digression. You need help from the community.
Yes,
but the community also sees you as a 17-year-old blonde girl from Minnesota getting off the bus in the Sunset Strip, having no idea where she is.
Even though I've got the 97 patents
does
and
not
all
matter,
of that stuff, it
because
doesn't
first of all,
matter.
you cannot patent science. They took away our ability to earn a living from doing science, right? You can do technology and patent it, but you cannot patent fundamental mathematics and physics.
Well, see, that's what I'm hoping. I'm hoping that they ultimately take the patents from me because they become basic,
Terrence,
general.
Let me tell you something. It is more important that you get a small number of us to say he did something than you fooled some patent examiner who has no idea what the hell's going on and can't actually earn a living the way he dreamed of being an engineer. And so, at some level, the most important thing that you've done is weirdly based on an error, so far as I can tell. So can you bring us a linchpin?
Bing, 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 bing.
Okay. And Jamie, could I trouble you for bringing up that same page over and over again? I'm sorry about that, brother.
Bingo linchpin. I'm going to bring you a whole lot of linchpins, but I have...
Just bring one.
No.
Okay.
Can't
But I have-
But we're
these are separate
dead air here.
Okay.
Okay, Howard's linchpin. Howard's extraordinary claims for the linchpin appear to mirror Green's extraordinary claims for the string.
So let's look at Terrence Howard filling up the dead air here, talking about the linchpin.
Okay.
The linchpin is the lowest common denominator of all matter, either seen or unseen. The linchpin is the internal dimensions of a torus. The linchpin is the universal wave conjugator for all things matter. It is the true currency of the universal flow because it is the common factor of all things. It is the smallest. It is the measurable constitution of a quantum or quanta, the smallest reflection, ultimately in collective potential of all things, which equals the multiverse. Blah blah blah. Let's now just watch our friend Brian Greene do the same thing. It's a great expression on Brian's face.
String theory comes along and suggests that inside these particles there is something else. So if I take a little quark and I magnify it, conventional idea says there's nothing inside, but string theory says I'll find a little tiny filament, a little filament of energy, a little string-like filament. And just like the string on a violin, I pluck it and it vibrates, creates a little musical note that I can hear. The little strings in string theory, when they vibrate, they don't produce musical notes, they produce the particles themselves. So a quark is nothing but a string vibrating in one pattern. An electron is nothing but a string vibrating in a different pattern. A neutrino, nothing but a string vibrating in a different pattern still. So if I take all of this back together, I have my ordinary orange. And if these ideas are right, they are speculative, but if they are right, deep inside the orange or any other piece of matter is nothing but a dancing, vibrating cosmic symphony of strings.
Okay. Now, if you take what he just said, this is entirely respectable. This is a Columbia professor lecturing me for 40 fucking years about what they're going to do one day when they grow up. That everything is just a string. And just the way a violin can vibrate in different modes, all of the particles come from this excitation of the string. It's exactly how you sound with the linchpin. Now, string theory is not a terrible idea initially. It becomes a terrible idea when the string theorists suggest that nothing else has happened for 40 years, and they've sought to kill off every single person who has pointed out that there are other ideas and that they don't listen to their colleagues. And so, in part, you're going to incur an emotional penalty from me with the linchpin, which is a terrible thing because the linchpin is actually incredibly cool. So the same basic pattern, which is one thing explains it all, has a terrible kind of cadence.
Because I'm about to get you. I'm about to get you.
But my point is, this thing that you created is based on an error. And it's a beautiful error. And I think people are just not going to grasp it.
What's the error?
The error is that the arc cosine of minus 1/3 is not equal to 3/5 pi.
Garlic makes my feet stink.
Okay.
That was perfect.
Okay.
Terrence with the timing today.
I'm sorry. It may be the whiskey.
It is the whiskey.
Certainly helping.
But I'm
Certainly
not
helping.
mad about it at all.
All right.
No, it's hilarious.
So what's going on is that inside of a tetrahedron, if I understand you correctly, I've got these vectors that point out towards the vertices. And between any two vertices, any of the four vertices, there's one of the 6 edges.
Right.
What's the angle between those two vertices as measured from the center of mass inside of a tetrahedron?
Still be at 120 degrees.
No, it's the arc cosine of minus 1/3.
That's what you're talking about.
That's what I'm talking about.
Okay.
Now, you say this is an undiscovered geometry. Now, why is that an undiscovered geometry?
Well, because they gave me the patents.
No. You got to stop that with the patents. I don't give a shit
I
about
did
these
the patents because I have watched so many people come and take somebody's work. So it was a protection.
Okay, we've covered the patents. Enough.
Okay. My claim is that what you discovered is a little bit like even temperament. Now, even temperament is a lie. Do you know about even temperament?
Yes.
Okay.
Yes. They're going up to 440 instead of 432.
Well, no.
Keep retucking it back together. It's an attempt to modulate or keep everything, start right back at the beginning and avoid the Pythagorean comma, avoid the necessary expansion.
Now we're talking the Pythagorean comma. The difference. All right, Jamie. Can we get the 12th root of 2 raised to the 19th power?
Good luck with that, Jamie.
Come on, Jamie.
No way.
Well,
Show it on a calculator.
all right, I'm going to do this Terrence Howard style. There's a flaw in all of mathematics and all of music. Take out your calculators. They won't allow me to project it at Oxford. So if we take the scientific calculator, turn it on its side, take the number 2. Okay. 2. Now, we have an x root y. Can we find root right below that?
Oh.
Yeah.
Try it again. 2.
Okay, 2 x root y, and then do 12. Just type in 12.
Hold on, sorry. I was going to show it. I'm not going to show it.
Okay. And now raise that to the 19th power.
That's this one, right?
Yeah. Oh, shit. It's almost
The
3.
speed of light.
It's almost 3. It's 2.9966. That is, if we take the national anthem, can you sing? I think you can. Give me Oh Say.
Whoa, say.
Okay, now take from Say and get me to Land of the Free.
To the land of the free.
Okay. That is supposed to be the ratio of 3. But if we did it on a harmonica, and the harmonica was properly tuned, sorry. That's not going to be 3. It's going to be 2.9966. Because the reason we divided that octave into 12 parts is that we couldn't figure out how to get 3 to be perfect because what you said, Pythagorean comma, which most people don't have any idea of. By the way, you have to get Jacob Collier on the show.
We call it the percustrian fifth because when I put these together,
Yeah.
you'll see that there's points where they will not connect because everything is expanding by phi. And that expansion.
You've got a Pythagorean comma in the middle of your linchpin.
Yes, I do.
Yeah. And
With 109.109.
yes. Rather than 108.
Yes.
You bastard.
Yes.
Yeah, so I caught you.
Okay, well, you didn't catch me. I just used a little thing that they don't know about.
No, I know about and the reason.
But
Wait.
I ain't going. Keep
Terrence,
talking.
come back here, Terrence.
Back. I'm about to bring you something. We're talking about this.
Terrence.
I'm coming.
Terrence,
I'm
come with.
I'm coming. I promise you. I'm coming right over to you. I just want to have these so when it's time to talk
Terrence, I don't think you understand the dead air principle at the JRE.
Dead air principle. I'm here. As long as I'm here, everything is well and alive.
Terrence, okay. So the reason that you came up with an undiscovered geometry is that you figured out something that is analogous to even temperament, which is if you shove a pentagon, which should have 3 radians distributed around 5 angles, in degree terms, that's 108. But the angle between the vertices of a tetrahedron is 109.47 and
Yes.
change.
0.47.
And so effectively, the same game that we played when people like Bach started playing with even temperament is, where do you pay for even temperament?
Well, you end up paying for it in the expansion of the song. It does not follow a natural
That's
expansion.
true. There's no circle of fifths. There's what?
There's
Spiral of
there's
fifths.
a phi.
Yeah.
There's a phi.
And you know what the worst note is? The worst note?
C and between it's C and B and E and F hitting at the same time.
No. You're saying something different. I mean that in the do, re, mi, fa, sol, la, ti, do, right? Do to me is an abomination, right? Can we do I can turn?
Yes.
Left a good job in the city. Let's go.
Left a good job in the city,
Okay.
working for a man every night and day. But I never lost a minute of sleep, thinking about the way things might have been.
Don't know the
Big wheels keep on turning, Proud Mary, keep on burning.
Keep on burning now.
Rolling,
Oh Lord.
rolling,
Oh Lord.
rolling down the river.
Rolling on the river. Okay. It's basically Mary Had a Little Lamb, right? But it's much cooler. Now, left a good job in the cité. Cité is going to be the third, and that third is wildly sharp to the Pythagorean third. That's the penalty we pay for dividing the perfect octave, right? Can you give me somewhere in Over the Rainbow?
Somewhere over the rainbow, birds fly.
Way up high. Let me see, what would it be?
I feel like I'm in a boxcar.
I feel like I'm on the launching pad where the UFO lands on Close Encounters. Do, 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 do,
All right,
do.
somewhere is a doubling of
it.
frequency, right?
Right.
The doubling is perfect. The fifth is a lie, but it's a good lie. The third is an abomination. It's not until you get to 53 notes, which the Turks use, that you get a better fifth and a better third. You get a better fifth at 29 notes per scale,
Yes.
and you get a worse third. So there's no reason to do
It's the
that.
12th, the 29th, 53rd.
Yeah. Now, my claim is that you pulled off the same thing by finding a cheat inside of the linchpin, which is why it's genius. And I don't even think you know how genius this thing is my guess.
I'm about to show you noble gas,
Oh,
and
stop
I'm
it.
going to show
You're
you
gonna
matter.
fuck the whole thing up.
So,
Listen to me. The number of edges in a tetrahedron is what?
and the tetrahedron is
6.
6.
And that's why you have 6 pentagons. But these 6 pentagons are not, either they're not perfect or they're not joined perfectly. You put 6 motors in these things with propellers, and you have 6 degrees of freedom.
There you go.
You have an object. Well, so we talk about pitch, roll, and yaw. But those are basically, if I understand correctly, the basis vectors for the Lie algebra of SO3 or spin 3 or SU2.
What's Lie algebra?
Well, so the idea is I have a rotation group of symmetries of this object about its central vertex. Okay?
Right.
And that's one of the things. You can put one of these things up, and with 3 degrees of freedom, I can spin it, right, like a full-on UFO, and just have it moving in crazy ways that nothing else can move. Because a quadcopter has only 4 degrees of freedom because it's got the 4 motors.
This is unlimited.
Okay. Well, but it's going to distract us. Let's
Why?
get to
That's
that
it?
in 1 second because
Okay.
that's super cool.
Okay.
By the way, that's a CGI.
Yes,
but I've
that's a
actually
CGI.
seen
I'm gonna
I've
show you
seen
the
guy
real
actually flying this around, so I don't want to do this.
We've got like
Okay.
19 of them. That's actually.
So what's going on with this is that you have 3 degrees of freedom, which is the rotations that I need here. But you've got 3 extra degrees of freedom to move in different places. Now, there's something called the affine group, which is the semi-direct product of SO3 with the R3 group of translations.
And the SO3 has 8. It introduces the chromatic aspect of.
Don't go chromatic. Just
Don't go chromatic,
You've got
okay.
something brilliant.
Okay, I'm listening. I'm just trying to
The-
understand.
The best thing that I've seen out of Terrence Howard, that I will tell people, this is why you never throw the baby out with the bathwater. And I don't know that you invented it. I think you did.
I did invent
I
it.
promise you, I think
No,
you
I
did.
didn't invent it. It was given to me. An angel gave that to me, and I'm sorry that everybody.
Terrence, I'm
don't
sorry to
believe in
say
that.
this. There's a way in which we all feel pressure to give away the genius stuff that we do to some higher power. This is why if you ask like Khabib Nurmagomedov, like, how do you do such great things? He'll say, mashallah, or astaghfirullah, right?
Inshallah.
Alhamdulillah, right?
Inshallah.
Because Islam is very good about, you always give away the compliment because you can't hold it because it'll cause you an ego distortion. This thing here has 6 degrees of freedom based on the relative speeds of the motors that you put into it. Plus, there's an affine group called SO3 semi-direct product R3, which has 6 Lie algebra elements. That means that this thing can potentially span the Lie algebra. And if you have a trackball over here as a controller, and you put like 3 theremins so that you could control in 3-dimensional space, you potentially have a drone that can rotate itself in 3 dimensions and get anywhere based on these 6 objects. Now, I could be wrong about that.
No, you're right. We've actually done that. So,
Okay. So my claim is, if the only thing you'd done, forget the art, forget the science, forget the this, forget the that, if the only thing you did was to introduce an error, which is 109.47 is not exactly 108.
But 108 is that key of A, which is.
God damn it, you won't stop.
I'm not stopping. I'm working with you.
I know.
Keep going. All right. You talk.
That is a really cool grade A idea until I hear that somebody else did it, or that when you machine this, because this is the thing.
Now, this is when you put 4
Okay.
of them together.
Now, the thing is, it's very cool if you take what Intel does with drones, where they sort of synchronize these swarms. This thing comes together and it forms a stable structure. Now, if you look at it, the tolerances that you've built into this thing, because these pentagons do not exactly come together,
109.47
is not 108. That thing within engineering is like even temperament. Even temperament is a lie. It's a fraud. But, oh my God, all the most beautiful music in the world is built on even temperament.
But look at what it generates.
That's what I'm talking about.
You put 4. Now, 4 of these come together and make this. 4 of these come together and they make this larger structure that is the same exact thing. So that's not
Terrence,
a lie.
It is a lie.
This
You're
right
trying to
here
build the
is-
whole universe
I'm
off of the linchpin.
defining something new.
You are. To the best of my knowledge, by the way, I looked at this years ago. Wait.
Hold on. No. Before you go there, this is the other side of it.
Yeah.
This is what's very interesting. Like these, they'll come together and meet. You can see where they meet up.
Yeah.
Their natural meeting up.
Yeah.
Now this one looks exactly like this one, but they don't have the same mixture. So what this is creating, this is actually showing. This is the equal and opposite. This is matter. This becomes the antimatter of it.
I can't stop you doing that.
You can't stop me.
I
I'm so
know.
sorry. I'm my own worst enemy and my own best friend.
You know what? That was a beautiful statement.
But what I'm trying to say is the fact that they keep, and these 4 will keep. This is just the magnetic, what I consider the magnetic field.
You see, you stopped yourself.
I
really appreciate
consider this to be the magnetic field because they're expanding at the center, and magnetism, in my language, magnetism expands out and becomes greater.
And you know when you just said "in my language"?
In my language.
That's what I just did with the Terrence product. In other
You
words,
said in your language.
I'm trying to get you to stop pissing my community off.
I don't want to piss them off.
I know.
I want friends. I need friends.
Terrence, that's why we're here, right?
But this
Okay.
right here, when you have and these will keep bonding with greater ones and keep making the same
The point is,
structure.
it's good enough within engineering tolerances to be a dodecahedron.
This dodecahedrons are. I'm not going to teach.
Now,
I'm sorry.
if you, Jamie, can we bring up T4 bacteriophage capsid? Because I think, do you know about what a capsamere is?
No.
All right.
I know what a pap smear is.
It's the second
had
time you
one
did that.
last
I
week.
enjoyed both of them. Okay.
I think you got a bad doctor.
Okay. Now, let's do the one below the cartoon. So you see where it says collared sheath? Let's do, yeah.
Oh, those are these quick things that run along. They move so very quickly along.
No, you're
this-
talking about something else. You're talking about a transport thing. This
Yeah,
is a
this looks like-
virus.
this is a virus. It looks like the transport things.
This is phage lambda. And what this thing is, that thing is an icosahedral capsid. So all of the nucleic acid is upstairs in that compartment, but it's not a perfect icosahedron because it has the elongation of some triangles and the truncation of others. Now this thing is an example of imperfection in nature, right? So nature wanted to do something very rigid to protect the nucleic acid by coming up with an icosahedron, but she didn't do a perfect one. Can we find any other that, like, you see above that one, that's way too perfect. It's not true. That's a good one. So in some sense, what you find often enough is that nature actually chooses imperfect perfection.
Nested.
Yeah.
They're just nesting instead of...
Now, what the way this works, can we look up capsomere? Again, I'm way out of my element. C-A-P-O...
Something different.
C-A-P-S-O, capsomere. Yeah. And then images. So the idea is that you have these little units, which are very much like your drone units, your linchpins, that come together to form capsids. So when can you hold up one that encases a dodecahedron?
Oh,
like right here.
Yeah.
So that is like a capsid made from capsomeres. So I want you to spend some time on the protein data bank. Maybe let's go to the protein PDB capsomere. And you'll get an understanding of all the ways in which nature has been doing this engineering that we've been learning from. Maybe actually just go to the site PDB. Yeah, let's try that. Herpes. Basically what these are little nature's version of linchpins that come together to form platonic solids, which are the triangular platonic solids are valued because the triangle is a stable structure. If you think about a square can become a parallelogram very easily. So they're not very, engineers will use triangles over squares. What you need to do, in my opinion, is to figure out the Eternal One's understanding of these structures and how he or she creates these things with the stability that actually use the imperfections just the way you were using the imperfections. And by the way, I did look at this years ago and totally discarded it because 108 wasn't equal to 109.47.
Right.
It's close. And the fact that you're willing to deal with something doped with imperfection is what actually is the genius akin to even temperament.
Well, it's like, how do you walk? You don't walk by a perfect gait.
Yeah.
You walk by moving past the point of equilibrium and catching yourself.
Well
it's
said.
It's the catching.
I don't know how to think like that. I think perfectly, not imperfectly, and it's to my detriment in many situations.
Well, you've got an incredible mind.
As do you, sir.
Recall stuff.
Can we go back to the main page? Because another thing that I see you taking a lot of guff for is the periodic table. Now, I don't like your periodic table, but you are also the only person I know who's pushing into the public consciousness the understanding. Okay, so first of all, do you know Stanley Jordan?
Not by name.
All
You
right.
smoke weed?
Stanley Jordan is one of the, I don't even want to call him a guitarist. He's an alien intelligence from another universe. But if you go up and you click that, people have been saying that Terrence Howard is making up this thing about the periodic table and the sound of the elements. And I want you to hear what he calls sonification.
The ionization energies of the elements as represented here in a periodic table, and we are going to produce tones representing those energies. The way that this app works is each one of these elements in the table is actually a push button, and I can play tones with these push buttons. The settings in this control panel here will determine how those energies will be converted into tones that we can hear. First of all, we're just going to look at a few of the controls for now. See, we have transpose frequency. The frequencies corresponding to these ionization energies are extremely high, so we have to transpose them down to a range that
As you said.
So here we're going to transpose it down, in this case, 42 octaves, negative 42. So let's start with hydrogen. If I transpose it 43 octaves down, I get that tone. Or I can go 44 octaves down. I can also transpose it chromatically. As you can see here, I can go up and up again, and up again. But normally I set that at 0 and just leave it there, and I only change the octave. Let's go back to 42, and I'm going to show you some of the other controls that we have here. The duration is in seconds, so here we go, 1 second long. Or we could go longer, let's say 2 seconds. And the damping factor controls how quickly the tone decays. 3 is kind of like a nice...
So what he's doing is he's preparing you for the fact that he's going to play the periodic table. And by the way, I just want to say this thing. Stanley Jordan is a friggin' mega genius.
I see that now.
And what you're talking about, I was talking with him about several years ago, and what he was going to do is to mine the periodic table for the music of the elements and also go beyond that for molecules.
See,
Okay.
I tried to do the same thing, and I called
People treat you like you're nuts.
UCLA asking for the prime resonant frequency of the elements, and they wouldn't give them to me. Nobody would give them to
Well,
me.
because in part, wait, listen to this.
Boron, carbon, nitrogen, oxygen, fluorine, neon. Now, what happens is, as you start listening to these, you start to notice
That's an
patterns.
E sharp.
Let me go and go through this second row again, but I won't say them. I'll just go ahead and play through them. Kind of a beautiful melody, isn't it? Now, these pitches that we're hearing are determined straight from a calculation based on the actual energy of the element. So we are getting tones that you couldn't necessarily play on a piano. A lot of them would fall in between the keys. So they don't fit our conventional
They're
Western
sense sharp or
musical
sense
pitch
flat.
system. But if you want it to fit, we can enable this. It says quantized pitch. So all these pitches are slid to the nearest note.
So when you
in the
say key of
chromatic
E.
scale. The chromatic scale just means all of the notes that we could play on a
And
piano.
I'm
That's
talking
the best
about
way to
432
explain it
when I'm
quickly.
talking
what I'm
about
gonna
the
do is I'm
key
gonna
of
go through
E
these again a little more
on it.
quickly,
Well, you
and
make
I'm
an
gonna
error
shorten the
again.
duration.
So you say this thing about hydrogen 40.5.
Well, no, I
Hertz.
wasn't saying.
Wait a
no,
second.
no,
Wait a second.
But I wasn't saying that hydrogen is 40.5. I was saying that the key of E is 40.5 hertz and doubles to 162. Those things.
Yeah, but you said it
to
in a
move-
very authoritative way. And the
but
one
you-
and the
if-
40.5 is not 40.5 hertz. It's 40.5 megahertz associated not with hydrogen but with mercury.
But you have to keep once you keep doubling that.
But wait a
you'll
second,
get
Terrence.
to the.
You activated a bunch of chemists who said, I don't know this frequency.
Because they're looking at 440. They're looking at their.
No, 440 is an
Their
irrelevancy,
440
Terrence.
to it.
440 is concert A in a time when we've decided that that is concert A. If you were to use the Hindustani system, let's say, instead of do, re, mi, fa, sol, la, ti, do,
It was ut, re, mi, fa, sol, la.
no, they do sa, re, ga, ma, pa, sa, re, ga, pa, da, pa, ga, sa, re, ga, re, sa, re. They use a different...
I did the Cephalgian. I did the Cephalgian
I know.
skill. That's what I did.
But I'm saying this
Sorry.
is that for North India, right? It's an irrelevancy because everybody's allowed to tune their sa to a different tone. They don't have to tune their sa around A440 because there's only 3 instruments. There's a tabla which doesn't have that tone as an important part. There's a tanpura which is tuned to the soloist, and the soloist determines what their sa should be. So can we do sa re ga? So in that system, the absolute value doesn't matter because you can tune it to whatever you want to tune it. You're not trying to come up with an orchestra. It's only the orchestral aspect of Western music and the need for even temperament that forces us all to listen to the concertmaster as to what A440 is, right? Okay.
Joseph Goebbels pushed that around the world.
Okay, let's not do Joseph Goebbels. Just keep drinking whiskey. What you have is a situation in which nobody understood what you said about the periodic table, except for a tiny number of people. Now, if we go to that page, Jamie, that we put up, back below that. The Sound of Hydrogen from WSU. So this is an academic page dedicated to the idea that you're trying to figure out how to play these things, and this is the sonification. Now, you attribute more meaning to this, I think, but you need to know about a guy named Luca Turin, who's a buddy of mine in the UK at Buckingham University, which is trying to do some wild radical stuff. They are working on the idea that smell is not based on shape, but is based on frequency of the valence electrons, and that particles that vibrate the same way smell the same, even if their shapes are different. And if their shapes are very similar, but their vibrations are very different, they don't smell the same. So there's an entire book called The Emperor of Scent about the academic, like all the people who try to push you down. They're trying to push Luca Turin down as if he doesn't know what's going on. He's written the Bible of perfume. I don't know if you like scent.
I do.
He understands the vibratory quality of scent. And so trying to sort of synesthese these things by saying that everything that has frequency and vibration can be understood in each other's terms is a small freak community of very smart people trying to do what it is you're doing. The only problem is you gave us, people ask me for an analogy. What do you think of Terrence Howard? That's all I got for like a week. Can we pull up the
Terrence Howard, Joe Rogan Experience?
Yeah. No. We're having that right now. The Janet, it'll come up as Janet Left Step periodic table. What you did to the periodic table was, by the way, what a gift that I hate the periodic table. Can't stand it. The problem is I had to analogize when people ask me what I thought of you. Let's click on that thing. That periodic table is one of the alternate periodic tables that's much more in favor with people who are mathematically minded like you are, rather than the Walter Russell periodic table. Because what this does is it uses the quantum mechanics to stop with those exceptions. Isn't it weird that there's like a footnote in the middle of the standard periodic table in which you just say, well, these things are exceptions to the rule? This is an attempt to use the electron orbitals in terms of the spherical harmonics, where you're looking at complex valued functions on the two-dimensional sphere. And this sort of Aufbau principle, imagine that there was only a Coulomb potential centered at the origin in a hydrogen situation. You would go along and say hydrogen first, helium, then lithium, then beryllium, then boron, carbon, nitrogen, etc. And this is the way in which you would build up the outer shells of the electrons, in which you have this principal quantum number, which is basically the energy level, but then the L quantum number is what we would call a highest weight for a highest weight representation of SU2 or spin 3, which is the double cover of SO3. Mm-hmm. That first one is one-dimensional, but it's spin up and spin down, so you get two elements. The next one is going to be three-dimensional, but you're going to get 6 elements. And then you're going to get 5-dimensional because it's SO3 that determines the representation theory. This thing is what I wish you had given us rather than the Walter Russell thing, which is sort of a historical artifact. Now, no offense, but the big problem is that if you are trying to talk about like hydrogen, and then you imagine carbon is an octave above, I think is what you said, doubling the frequency. What is that thing below hydrogen? And you say, no, it's too dense to be perceived. Like, bullshit.
But there is ultra low frequencies, even though we cannot hear it.
Yes, but
there's ultra low frequencies, and that's what I'm saying.
That's where your analogy broke down, Terrence.
No, because hydrogen sits in the same exact position as carbon does when you're looking at it.
No, it doesn't.
It doesn't come off at the same coloration. It doesn't have the same tone.
Terrence, you're talking about a periodic table from like 1926. something like that. And Walter Russell had some decent intuitions that he instantiated terribly. Now look at all this shit that you're doing. And look at the fact that he's locked in 1926. Dirac is not going to come up with the Dirac equation to supersede the Schrodinger equation for another 2 years. Quantum electrodynamics isn't going to be born. The neutron isn't going to be discovered until the early 30s. And you're taking the wrong fight. You're saying when David Tong, here's what I really didn't appreciate about what you did. David Tong said, this is all a lie. And you took the wrong meaning from that. What David Tong was saying was different. David Tong was saying, we teach hard little ball theory. Right? There's an up quark and 2 down quarks in every neutron, and 2 up quarks and 1 down quark. And they're all little hard little balls stuck together by rubber bands. And then we've got 1 electron going crazy around it. And he's like, that's not what's true. And what did he say? It wasn't a lie in the sense
He said that's the best knowledge that we have.
He said, I don't know how to
present."
say the word field to a 7-year-old. They're fields. They're not hard little balls.
But that was my problem with David Tong, because here I showed him.
You don't have a problem with that.
No. The problem that I had was with his response to me. Was here I was showing him these are the wave fields that your particles sit
Every time you
within.
teach, you
That's
incur
the
a penalty.
problem. But see, that's the problem. How do you not teach when you have something new?
I'll tell you how to do it. Okay? First thing is, you try to figure out who's ethical and who isn't. I'm not kidding around with this.
You got to be Jesus Christ to figure that out. Because most people, they have a good faith.
Terrence, let me ask you a question. Have I been fair to you this time?
You've been amazingly fair.
Okay.
You've been
have I
very
been
kind.
uniformly? No, I haven't been uniformly kind.
You have. You've been honest.
Well, you're talking to me about my heart. My heart is open to you.
No,
right?
you've actually talked about the things that I've talked about.
That's right.
You've given me criticism on things where I've made mistakes. You've told me where
this is
I've
not
offended
available as a
people.
service in academics.
I know.
In academics, basically, it's a closed little world, and if you don't come with protection, we stab you in the eye. This idea that Neil said about why doesn't he just submit to peer review? It's
I
the
did.
biggest bunch of shit I've ever heard.
We've
in my
got
life.
2 papers, the geometry of the proton. Did you get to see that?
Can we pull up the Neil stuff on that I prepared on that page? Because I cannot believe how disingenuous this is. He calls you the worst insult in academics, which is there was a study called
Dunning-Kruger effect.
is both an effect that is studied and the ultimate insult. It's basically your mama, right? Mm-hmm. Let's just click on that and see what happens.
So I spent a lot of time on it, and I thought, out of respect for him, what I should do is give him my most informed critical analysis that I can. In my field, we call that a peer review. You come up with an idea, you present it either at a conference or you first write it up, and you send it to your colleagues. It is their duty to alert you of things about your ideas that are either misguided or wrong, or there's the calculation that doesn't work out, or the logic doesn't comport. That's their job. Not all ideas will turn out to be correct. Most won't be. But to get to that point, you need to know things like, what has everyone else said about this same subject? Am I repeating someone else's work? Is this a new insight that no one else has had, but has foundations that are authentic or legitimate or objectively true? Am I making a false assumption? Am I making an assumption that someone else has already shown to be false? All of this goes on the frontier of science. Let me make it clear that I'm delighted when I see people with active minds trying to tackle the great unknowns in the universe. It's a beautiful thing that people want to participate on this frontier. What can happen is, if you're a fan of a subject, let's say, a hobbyist, let's call it, it's possible to know enough about that subject to think you're right, but not enough about that subject to know that you're wrong. And so there's this sort of valley in there, a valley of false confidence. This has been studied by others, and it's called the Dunning-Kruger effect. It's the phenomenon where a little bit of knowledge, you over-assess how much of that subject you actually know. And then when you learn even more, you realize, no, I didn't know as much as I thought I did. So then there's a sort of a lull there. And then when you learn even more, you come back up. Ultimately, learning enough to know whether you were right or wrong. To become an expert means you spend all this time. It doesn't happen overnight. You can't just sit in an armchair and say, I'm now an expert. It requires years and years of study, especially looking through journals where new ideas are published and contested. That's what we have learned is the most effective means of establishing that which is objectively true, or determining that which is objectively false. Both of those work hand in hand to move the needle on our understanding of the universe. I'm going to read you just my opening line here. It's titled 1 × 1 = 2.
Okay.
So I lead off.
So that was now if we go below that, what do we have? Is that let's try that.
Hi, Sir Arthur Eddington, an astrophysicist, provided the first experimental evidence for Einstein's general theory of relativity, which, by the way, was published in a peer-reviewed journal. Crazy idea. The platform to be accepted for the ideas is not social media. It is not Joe Rogan. It is not my podcast. It is research journals where attention can be given on a level that at the end of the day offers no higher respect for your energy and intellect than by declaring that what's in it is either right or wrong or worthy of publication or not. I wanted to post this to my website so you can see my comments mixed in with his treatise, but you got a sense of it. Thanks for listening.
Okay. I want to be very careful about my words. Is there anything below that we've put together? This is let's go above. This is Neil deGrasse Tyson. Just so you don't feel bad about yourself, talking about me and my theories based on a question in an Ask Me Anything. Will you be able to talk to Eric Weinstein about the new theory of geometric unity? This is from 2013. We are all wondering about that. Cosmos is not your normal talking head documentary. In fact, it's the feature of the original that enabled the series to live for an entire generation beyond the shelf life of hundreds of other science documentaries that came afterwards. So the answer is no. Let me explain where you are. Neil is not unaware that you are never going to get your hearing in a peer-reviewed journal. Your ideas are going to come through. You're a self-taught, autodidact polymath. You haven't been cleaned up. You haven't been taught how to speak properly. You don't know the fact that when you say loop, we know fixed point. I know how to do all this stuff, right? You're not getting a peer review from me. I know a lot more than you do about a lot of this stuff. You're getting an elite review. And my elite review says that a lot of this is bathwater, but a small amount of this is baby. And that's not available anywhere. It's not available in a university. It's not available in a journal. That's available on the Joe Rogan Experience. And Neil's right. If what you want is peer review, you should go to a journal and they will laugh you out. They will take one look at your email address. And if it doesn't end in .edu, I promise you're not going to get hurt.
Do me a favor, Jamie. Can you pull up?
Let him finish.
Hold on, not that because
But let him finish because this is a sustained thought.
Let's go below where we just were, Jamie. I don't think Neil deGrasse Tyson actually knows the history of peer review. This is Google Ngrams, and it tracks how often a phrase is found in the corpus of English language books published in the world. Peer review basically begins in the mid-1960s. Now, there were various forms of review. Editors, in particular, were very distinguished individuals who were chosen to not peer review things, to simply take a look at things and see who should be published and who should be not. Can we bring that back up? More or less, from what I can piece together, Ghislaine Maxwell's father, who started Pergamon Press, destroyed
Jeffrey Epstein's Ghislaine Maxwell?
Correct. he figured out how to destroy science and make a fortune by blowing out the number of journals and forcing every university to subscribe to every journal that he could figure out how to publish, because to not subscribe to all of the journals required an admission that you had an incomplete library. So he diluted the quality of the editorship of the leading journals. This was a very informal, high-quality enterprise. Now, most of the destruction of science, in terms of how high quality it used to be, has taken place relatively recently, post-Robert Maxwell. Because now we have an enormous number of journals staffed by people who can't spot publication cartels where we agree to cite each other's work and we agree to publish stuff, pay for play. All of the nonsense that you see with irreproducible research comes after this peer review thing. The peer review thing got woven in so that people think that the scientific method and peer review are effectively the same thing, where one is an unwanted infection from the biomedical universe, which had peer review much longer than everything else. Neil is giving you a very cursory back of the hand brush off. Okay?
I felt it.
All right.
I
I'm here
accepted it.
because I love this man, and this is a higher quality environment. We have to sort out what happened with Tony Fauci and the origin of COVID. I was very distressed when Joe was sort of credulously accepting everything that you were saying at a level where he did say, look, I can't evaluate this. And he was letting you have your piece. Joe has established an extraordinary thing where he can call on a Roger Penrose. He can call on all sorts of amazing people.
He called on you.
Well, he has lapses in judgment, but he has his good quality. My point being that this is actually what science was supposed to be. We were supposed to listen to each other, not go after each other with an ice pick to the eye. We were supposed to try to figure out the best version. Remember at the beginning of this where I was trying to say, look, I want to do the best version of your idea and build it up.
So what you're saying, though, can I just summarize this? What you're saying is that Neil deGrasse's understanding of peer review is flawed.
Sure.
And that it is not really available to someone like Terrence.
It really isn't. He knows that. You see, peer review is not one thing. One thing peer review is the ability to get rid of the axe murderer who's just wandered into your office with a manuscript in red crayon.
Well, while
says,
you guys are talking this, I've got to run to the bathroom.
Go ahead. Because just this alone.
It's an important point.
Yeah. Okay.
So what Joe and I were just talking about
Yeah, we're back from the bathroom break.
is what is peer review actually and why is it controversial? So imagine that you have 4 types of people, right? You've got 2 establishment figures, one of whom is screwing up the field, who's in a very powerful position and should be removed from the impediment, being the impediment to progress that they are. Another person is an establishment figure who's killing it. They're the establishment because they're supposed to be the establishment. The establishment has recognized how valuable that person is. Now you've got 2 other figures. You've got an axe murderer who desperately feels that they've got the secret of the universe and anybody who doesn't understand them is a horrible person. Or you have a heterodox person who actually knows what they're talking about and can overturn the established order, which is where you get a revolution. Peer review just sees establishment versus non-establishment. It will lock in a terrible idea for 40 years. And it will stop somebody coming from outside. It will reapportion credit. So suddenly you do a lot of work and somebody, this is this thing I said about gripe and swipe. We notice one flaw in your work and we take the entire corpus that you've produced away from you and we publish it under our own name. I can tell you a dozen terrible stories of peer review where people have confessed to using peer review as a weapon against their colleagues, particularly younger colleagues. And to simply say peer review, it works, bitches, holy cow. How can this be? I thought I was upset with some things that you had said and done. No. They're dwarfed. They're dwarfed by this. This is so disingenuous. Basically, This is saying, please submit your stuff from a gmail.com address. We'll take one look and say, it doesn't look like .edu to me. And we'll throw whatever you do in the trash heap, and we'll say, well, you got the benefit of my peer review. Now, you look at what Neil said about your stuff, and by the way, he's right about 1 times 1 equaling 1. You're wrong about that. That was your opener. You picked a terrible move. On the other hand, you heard what I said about the linchpin. It was a combination of bath water and baby. I do not have any economic or authoritative interest in taking anything that you've done and putting it under my own name. I am simply here to help you. And when we talked about the angle and all this stuff, I can tell you that that's a great idea. It may have been had by somebody else because I don't know, but I assume it comes from you. It may not work in practice. I think it's pretty promising. And I think if you don't do anything else and you create one drone that just does that really cool thing, it'll all have been worth it.
No, we've got
No. I know.
tons of
It's
those.
not-
It's now.
You already
just-
created this. You're obviously doing cool stuff. What I'm trying to say is we in science have lost the ability to talk to people who do flawed stuff from outside. All we want to do is get rid of you. And it's because we have this fake openness. We have a fake scientific method. Peer review has nothing to do with the scientific method. We got along fine without it. Peer review isn't even peer review. It's something called peer injunction, where your peers can stop you without shorting you. I'm happy to bet against you in all sorts of things that you're doing. And if you win and I lose, I'm on an unbounded negative experience. But if I block you and I won't short you, that's saying that I think you're dangerous because it's too dangerous to go short. And the idea that we're handing old people and established people and very politically savvy people the ability to block you without shorting you is unforgivable. So what I'm trying to do is I'm not pretending to be your peer. I know a lot more than you do. I'm giving you an elite review, and you're welcome. And the elite review doesn't find you as baseless as the peer review that supposedly got handed to you does. So that's, in part what I'm trying to get at is, in my field that I care about, for 40 years we've heard this unbelievable trope that only the string theory people are doing real work and everybody else isn't. And it's total hogwash. And there's no way we can get out from under these people. In the case of Anthony Fauci and Jay Bhattacharya, I was just with Jay Bhattacharya in Italy. You have this guy who has a PhD in economics, and he's a doctor, and he's a professor, and he becomes a fringe epidemiologist overnight because some bureaucrat who is probably in control of the bioweapons portfolio, because we signed these 2 treaties during the 1970s, the Geneva Convention and the Bioweapons Convention. He and Francis Collins suddenly convert a respected colleague into a fringe epidemiologist. And it's like, no, we're going to have a mutiny. And the mutiny is going to be based here because this is a place that you'd invite Tony Fauci and Jay Bhattacharya.
Oh, for sure.
Yeah. We could do any of that.
I bring garlic
Yeah.
We could have Michio Kaku
and
in
some
here.
crosses on the wall.
Let's have Michio Kaku and Brian Greene. Let's have a discussion about string theory. Let's fundamentally discuss neoclassical economics. Shall we discuss whether or not random mutation is the true engine of neo-Darwinism? Is that reasonable? Or do some of these crazy people who say, I don't know what it is, but random mutation isn't powerful enough to build proteins because stability is too difficult? The sad fact, Joe, is that you built something that has some credibility. And even though you think of it as, I just like having conversations with people and a lot of them are fighters and I'm just a meatball, we don't have any other place. We can't go to the National Academy of Science. It's too politicized. We can't go to Harvard. You saw what just happened with Claudine Gay, who's still a professor. We've lost everything. And podcasts, as dippy and shitty and as variable in quality as they are, JRE very much included, this is all that's left. And my claim is that I'll challenge Neil. I actually think that this is a better place to do review because I'm on the hook. And by the way, some of the shit that I've said is probably wrong.
The thing that pisses everybody off is the fact that I have the models behind what I'm talking about. When I talk about when we describe the electric field or the plasmic field, I've got models that define every aspect of that motion, and I'm waiting for it to be reviewed.
I will
to
short
say-
you.
I would love that. I would love that.
I'll take some of
because
your money.
I would love that. I would love that.
But I'll also try to help make them better.
But it's having the proof. And then, mind you, like Jamie, if you pull up the
But Terrence, you know what he's saying about like not being an expert and teaching, and then coming from the outside, and that it's It's like
It's
a
insulting.
It's insulting. It's a bad way to approach a concept, because the people that have been studying these concepts for so long instantaneously are told that they don't know, but you know, and that's offensive to people that are actual experts in a thing. I think the same ideas could be portrayed in a way that does not do that. The
I
same
have to learn that nomenclature.
It's just you're so much smarter than most of the people you're talking to. That's what the problem is.
And this is one of the failures of Joe's bullshit detector. In other words, you believe what you're saying, and you're obviously very, very smart, and you obviously have a huge amount of things that you've been introduced to. Like, how many other people bring up Hermann Grossman and geometric algebra and Clifford algebra? I think I'm probably the only other one in the history of this program to do that, right?
When I saw you mention Clifford algebra, I was like, okay, there's a commonality.
Right. Now, Sean Carroll for sure knows what a Clifford algebra. I'm not sure whether Neil deGrasse Tyson does. Brian Greene certainly does. But in general, this stuff doesn't get introduced in places like this. And then, and you'll watch this in yourself. I'll try to put a circuit in your mind so you'll know exactly the point where you start pissing my community off. Can we bring up the cruel tutelage of Pai Mei?
What's that?
I love chick flicks, and I think the ultimate chick flick, Joe.
It
Be
sounds
sensitive.
like my ex-wife.
I'm seeing you there
Be
watching
sensitive,
Legally
Joe.
Blonde.
No.
I'm seeing you right now with your socks on.
Let's go. Let's go earlier than this.
Is that from Kill Bill?
Yeah.
Oh, okay.
I can't show this. That's why we can't.
Yeah.
You gotta be more specific. I can't
Oh.
show this stuff on YouTube.
Well, the bride goes up to the top of these stairs,
Okay.
and Pai Mei asks her, "What do you know?" And she says something like, "I am acquainted with such and such so-and-so, and I am more than proficient in the fine art of Japanese whatever." And Pai Mei completely kicks her ass because she doesn't understand where she is. And my claim is that you need your ass kicked. And you need to apprentice to some of us who know more than you. And believe me, let me just tell you this. I've had my ass kicked, and I will get my ass kicked more, because you need some kind of humility. You're coming across wrong. By the way, never pick a fight with Jamie Foxx. Holy shit, is that guy good at everything.
I learned that the hard way.
Jamie, if you're out there, I totally love you, and what you did in Ray is just unbelievable. But that
He
guy,
does it in every movie.
he's so damn good.
Yeah, he's an insanely talented
He's an insanely
person.
talented person.
He's one of the most intelligent people I've met. I was sitting on the set of Ali with him, and I'm playing chess with him, and I'm playing a serious game of chess. He's having a conversation with two other people while he's playing chess with me. As if it's nothing.
Yeah.
And I play chess well. So I've never been more impressed with somebody who can compartmentalize, and he's an organizational genius.
He's whatever he is. But you know what? I had my guy. My guy was named Noam Elkies. I don't know if
Noam Elkie.
you never heard of Noam Elkies. Noam Elkies, I entered Harvard at 19 with a master's degree. Noam was 18. He didn't have a master's degree, so we were sort of, in a weird way, neck and neck. And everything that I thought I was good at, Noam was better. Noam, I played a little piano. Noam could compose anything. I mean, this guy's just like super genius beyond genius, right? And he wasn't a bad guy at all, but he was so powerful in his mind that like he composed, I think, an 11 by 11 crossword with no black squares. I don't know, stuff that just can't be done. And I thought, well, geez, there's just no point in competing with Noam Elkies. And one Christmas party, the professor named Raoul Bott heard me trying to play boogie woogie piano. And Noam sat down and like Raoul said, well, why don't you play us some boogie woogie? And Noam started playing what he thought was boogie woogie, but it was like Rachmaninoff. And Raoul would say, no, no, no. And Noam would go into Chopin, and then he'd go into Liszt. He was playing ever more brilliant things, and finally his brain just blew because he couldn't think through boogie woogie. But Noam then became the youngest professor in the history of Harvard University. And I realized that I had accidentally entered in a year in which a Noam Elkies was present. And by having my ass kicked repeatedly by this guy, I had to ask myself the question, well, what am I doing on this planet? What do I have to contribute? And all the things that I see a Jamie Foxx doing, he's not trying to do anything like this, right? There's a creative spark and a spirit in you that I really see and appreciate. It comes from an older era, and we don't have people like you in the academy anywhere. We used to have lots of these polymaths who would connect fields. And right now what we've got is a specialization epidemic. And as far as I can tell, what you need is some discipline. And you need discipline from coming into contact with people who know a lot more than you, who can educate you as to what we already understand, how to communicate those things.
And not just shut them down.
It's
well, that's
what
the
happened.
thing. And the epidemic we have is assassins. We have an assassin epidemic because the midwits in the system, all they do is see things in terms of like Dunning-Kruger, Dunning-Kruger, Dunning-Kruger. The funny part about it is that that's the midwits endpoint, is that they see heterodox thinkers and they can't figure out how to place them. And so they just say, if I can find one error, I can reject everything. And you keep triggering that, and that's
with
why
the
you are
one
where you
times
are.
one, but that's why I keep saying the 1 times 1 is more of a
It's
metaphor.
not a metaphor to us. It is life and death. You try to sneak 1 times 1 through airport security. It's like, it's just a Glock 19.
I understand that, but it was really to gain the attention.
They never do it.
To gain the attention.
Listen, you didn't
of
know, and
something
now
is
you
wrong.
know.
Well, okay, there's one more that's going to keep us from ever getting you through this thing. Can we pull up my page again?
And we're going to
I-
wrap it up with this one.
Yeah, I want to. I want to do this. It'll be a little bit.
4.5
Well, we didn't
hours
even. But we didn't even do the linchpin.
Terrence,
we're
There's
so
more-
far
okay.
down the road.
if we,
This is 4.5 hours.
okay,
Yeah.
I want you to take a look at the chemical engineering PhD, because if we don't do that, I can't actually help you.
Oh, that right there.
Talk to me.
Let me explain that.
Yeah.
Here I took over to what was the name of the university? South Carolina University.
Yeah.
I was working with Apollo diamonds. We were growing diamonds. And I had developed a way in which to grow diamonds larger than the 2-carat diamonds. I went over to South Carolina University and I talked to them about introducing the diamond process, into their university. They were going to give me an honorary degree.
Okay.
Now, I'm thinking they're giving me an honorary degree in chemical engineering because of what I'm doing. And it's just an honorary degree in humanities that they gave me. And so I went on the show and I was like, yeah, well, I got an honorary degree from them. But that ended up coming across as if I got an honorary degree in chemical engineering, which I don't have an honorary degree in chemical engineering.
Assume you did. An honorary degree.
Is worthless.
It's like, would you take if your child needed brain surgery, would you go to Dr. Dre?
No.
Okay. Here, I want you to hold this. As a guy who was 19 with a master's degree, Harvard University and I got into a fight. And it took me 7 years to get that away from them. And they would have been happy to bury me without it. Okay? That is blood, sweat, and tears. And the work that I actually started doing ended up in somebody else's name because Harvard University in part credited with them with it.
That's the PhD person?
When you screw around with a PhD, like this Claudine Gay, this woman needs to be fired. Okay? Harvard University needs to go back to the business of kicking ass and taking names and being the place that is the shining city on the hill. Enough with the anti-Semitism, enough with the woke, enough with the DEI. Don't ever let me catch you talking about Jim Crow mathematics. You're getting absolutely treated seriously for the serious stuff that you've done. You're getting treated properly for the wrong stuff. That thing about the PhD, it's basically fraud. What I'm saying to you is, I don't give a shit. Merit is merit. If I can catch you in a fraud, if I can catch you in a lie, I can catch you in an error, I don't care. My question is, what did you do? What was the cool stuff you did do? I'm not an assassin. I don't care if you, in part, exaggerated your achievements. I know what it feels like to be shat on. I know that you have no ability to fight what's being said to you from on high. Okay? What I'm saying is the only thing that matters is what you contribute in the end. And imagine that there was fraud, imagine that there were lies, imagine that there were errors. And imagine that the linchpin turns out to be the next level drone that defines everything, because accidentally there are 6 degrees of freedom and there's 6 dimensions in the semi-direct product of SO3 with R3, whatever. It doesn't matter. It's that cool. Gregor Mendel probably faked his Peapod experiments. And there's a guy named David E. Kaplan at Johns Hopkins University who said to me something, it's so beautiful I can't reproduce it. He said, physics is based on everything. It's the backstabbing, it's the frauds, it's the geniuses, it's the craftsmen and the workmen who get the job done, the experimentalists who toil on papers with 1,000 people. And this community of all of these people have come together to produce something which is something close to the source code of the universe. And if you're interested in that pursuit and you want to get rid of some of the baby fat and some of the bullshit, I'm happy to help. There's a lot of work to do it. It happens that I had done a lot of the work over my life, so I didn't have to put an infinite amount of energy into this. But what happened is that you created a mass delusion. And it was a mass delusion in part because we're not aware of what mass delusions actually are. They start with a nub of truth. They start with creative sparks of genius. So we're on the lookout for people who are just frauds, who have nothing that they actually can contribute. And what we don't realize is that you have these things about kayfabe, which are these melanges of reality and fakery, right? And they're interwoven. What you've produced is something that is part bullshit and part real contribution. And we don't have a system to pull it apart, and we don't have any experience for how to sense when that's what's going on.
But they consider the bullshit to be the 1 × 1 equaling 2, and the 97 patents, the supersymmetry.
It's not the 97 patents, it's not the supersymmetry. It's simply the residue, the reduction of when we get rid of all the stuff that wasn't supposed to be here, because you're a self-taught polymath. You're obviously incredibly intelligent. You're obviously not taught by the system. And you can't do that work all on your own.
No.
So you got to come in and you got to find somebody who's not looking to kill you.
And that's been the entire dance. What I've tried to do is introduce a new set of tools to the scientific and mathematical community so that they can advance past the Platonic solids. It's the Platonic solids I still see in a 2 or 3 dimensional position. And since we are living in hyperspace and hyperbolic reality, then we need to have tools that define that hyperbolic space so we don't have to go through Lorentz transformations and all of these unnecessary steps in order to get to defining curved space.
I think that the real story, Terrence, is going to be whether you can stop teaching long enough to accept some help.
I'm here to accept the help.
And I'm here to learn from you, because I'll tell you something. The linchpin is a good example of something which I didn't know. And to the extent that I did know it, I threw it away. And I think it's a great idea. And I think that the art, and I think that some of the higher dimensional stuff, and I think that a lot of this stuff has a kind of beauty that if John Horton Conway were still alive and hadn't been killed by COVID, I'd know where to send you. There's a guy, there are sphere packing people, there are combinatorists, there are all sorts of people who play with stuff in this realm. But the one thing that you've got to stop doing is that when you get on a program that has millions of people, you can't create one more mass delusion. I've got a Fauci mass delusion. I've got a string theory mass delusion. I've got a Biden is fine mass delusion. I've got a Trump is not a problem mass delusion. All I have, morning, noon, and night, is mass delusion on mass delusion. But people don't understand that the reason that these mass delusions get started is that there's a nub of truth in them. QAnon can't be total bullshit because it's got some core in it that's right and some craziness. If you think about Dianetics and Scientology, the first thing that they teach you about is the reactive mind. That's not a terrible theory. And then before you know it, it's Xenu and volcanoes, right? So what's going on is that people are not aware of how kayfabe works, right? Mm-hmm. Wrestling is one of the most dangerous, demanding sports of a certain kind. Now, it happens to be theatrical and pre-programmed. But if you've ever dealt with anybody, like the wrestling community suffers a death rate unlike any other sport in the world. What you have to understand is that kayfabe, and I highly recommend you look at my essay from 2011, is about what happens when fantasy and reality intermingle. And that's what you did on the last time that you were here. And I can talk to you about the fantasy, I can talk to you about the fraud and the lies, but I'm also going to talk to you about the contributions, the genius, and the insight. And what I want the world to learn is you're getting sucked into mass delusions that you're not properly imagining. There's almost always a core of truth and reality that the mainstream won't acknowledge. And then there's almost always a bullshit payload that gets leavened in because in some sense the mainstream is our official cult. And then all of the rest of us produce these other cults. And in my situation, I've gone 40 years and I haven't had a really deep conversation about GU, geometric unity, with my own community. Where you are is that you're in a world in which the number of people who are both competent and honest and ethical enough to have the conversation with you is dwindling to fewer than 10. It's been a pleasure and an honor to appear with you. Thanks for being a decent guy. I know that not all of this has been welcome.
This has all been welcomed. Any truth. And like I said, I take you up on examining and exploring these into the areas, because like I said, these are tools. I just want to offer a new set of tools to that community so that they can now advance past the points where we are.
Try not offering, because the first thing you need to do is not necessarily be a student. It's not a higher versus lower, but just recognize that you're bringing gifts and you're bringing problems, and it's very expensive to help you. But it doesn't mean it's impossible. And one of the great things about this program is that if there is anybody out there, they can hear it. Now, I'll be honest with you. I've been on this program maybe 6 times before. I am often astounded that I can reach all of planet Earth and there isn't a single soul who can hear me. And I think that one of the things you're going to have to reckon with is you're saying certain things and you may get hundreds and hundreds or thousands of responses and there won't be a single meaningful response among them. And I don't know what to do about that, but
stay off Twitter.
I did.
Yeah.
I did my best to give you whatever response I could.
All I really want is if you saw some benefit in the things that I've displayed and shared with you.
I want them in my house.
Then let's have a conversation. Okay. I've got a set for you.
We got
as
it.
A gift.
We're all connected now. Thank you very much, gentlemen. It was a lot of fun.
Thank you, guys.
It was very interesting, very informative. Thank you, Jamie.
Thank you, Jamie, very
Jamie.
much.
All right. Bye, everybody.
Thank you.